In this next video one shot series, we are going to look into a very complex chapter of IIT JEE mathematics. That is nothing but complex numbers. So this is one of those chapters in your JEE mathematics where a lot of students face problems. Especially if you look into this chapter, there are two parts of the chapter. The first one that talks about algebra of complex numbers. That is one part where most of the students are generally a little bit comfortable. But then there comes the next part of the chapter, that is geometry of complex numbers, where most of the students preparing for JEE exam usually face problem. So in order to help you out, I have divided this chapter into 13 problem types. And I am going to take problems starting from 2019 to 2020 in order to illustrate these 13 problem types and how to solve problems in each of these categories. So by watching this video, you will not just gain the insight into solving problems into complex number, you will also gain insights into what kind of problems JEE faced and made from 2019 to 2020 and what should be a strategy to solve those problems. Also, you will get an in-depth survey of PYQs from 2019 to 2020. So let us deep dive into it. There will be usually 1 to 2 questions in every JEE Mains paper based on complex number. Chances are that these questions can be from geometry of complex numbers. So before going into further detail, let us first understand what is the syllabus change from last year. You can clearly see that from this table that virtually the syllabus remains same from 23 to 24. Only change that we can see was from 23 to 24 where this topic of triangle inequality was removed. Now you can see that that has not been included in 2025. So largely the syllabus from 24 to 25 remains same. Now if I start with mind maps, you can see that in this chapter can be roughly divided into two parts. There is this part containing iota, definition of complex numbers, algebra of complex numbers, three very important concepts of conjugate, modulus, argument, and then three types of representation of complex number using Cartesian, trigonometric and exponential form. And then roots of unity or cube roots of unity as a subpart of it. You can see that this first part of the chapter we will call as algebra of complex numbers. This is the first chapter and usually students find this part easier to master compared to the next part. Next part is nothing but geometry of complex numbers where we will start with point and discuss the idea of rotation in it. Then we will go into line and see what kind of equations can be written in complex number for line. And then we'll go into circle and analyze the circle part. And ultimately we'll end our discussion with conic sections. You can see that the second part of the chapter is known as geometry of complex numbers. And in this geometry, especially the circle part has been the one which is especially important. I have kept for you a surprise till the end where I will give you an idea that in the last 5 years from 2019 onwards, how many questions got asked in which problem category. So you can do a weighted analysis that which needs to be given more emphasis in terms of preparation. So the first problem type is problems based on iota. Now we all know that iota is nothing but root of -1. But this alone will not help you solve the problem. So there are two small properties that you need to know. The first one is if I take iota raised to the power 1, it remains iota. But if I do iota square, then it becomes root of -1 whole square, nothing but -1. And again, if I multiply by one more iota, it becomes -i. And iota raised to the power 4, again, if I multiply by iota, it becomes minus of iota square, or minus of 1 into minus of 1 becomes 1. And if you keep doing this process, it will keep happening. That means iota raised to the power 5 will again be equal to iota. Iota raised to the power 6 will again be equal to iota square. Iota raised to the power 7 will be iota cube, and iota raised to the power 8 will be nothing, iota raised to the power 4. You can see that this process is cyclic in nature. And if you take any power of iota as 4n type, then you can see that the answer will come out to be 1. If I take 4n plus 1, it becomes iota. 4n plus 2, it becomes iota square, and 4n plus 3, it becomes iota cube. Another interesting property is if you take these 4 consecutive powers of iota and add them. So what it will become is iota plus iota square plus iota cube plus iota raised to the power 4. That is nothing but iota -1 plus minus I plus 1. And if you see that now the terms are cancelling out and the answer becomes 0. So the next property says that the sum of 4 consecutive integral powers of I will always be equal to 0. Now let us look into this question that was asked in JEE 2022. In this question, they are talking about equating two terms involving 1 plus I by 1 minus I.
So if you take this basic idea of 1 plus I by 1 minus I, and this idea would be asked multiple times, and simplify it by multiplying by 1 plus I numerator and denominator, what you will get is in the numerator 1 plus I raised to the power 2 by 1 square minus I square, and this can be written as in the numerator 1 plus I square plus 2I, and the denominator becomes 1 plus 1 because I square is equal to minus 1, and hence you can see that it comes out to be 1 minus 1 plus 2I by 2. So answer becomes nothing but I. So now if you look into the question once more, what is given to us in this question is nothing but I raised to the power m by 2 is equal to I raised to the power n by 3 is equal to 1. Now if I take this first one and equate it to 1, then for this to happen, the minimum value of m by 2 should be equal to 4 because I raised to the power 4 is equal to 1. So m comes out to be 8. And for the next scenario to satisfy, n by 3 should be equal to 4. Hence, n is equal to 12. So what they're asking, what is the HCF or greatest common divisor of 8 and 12? So that is nothing but 4. So answer of this question becomes nothing but 4.
So this question was given. Question says that if you have a set R, they have defined R as nothing but ordered pair A comma B, where A plus 5B is given as 42. Then what they're saying is there are m elements in this set. So let us do this part first and then move towards the next part. So if I start with this first part says that A and B are nothing but natural numbers. So what I can do is basically I can write A is nothing but 42 minus 5B. So now since A is a natural number, it will be greater than 0. If I put this greater than 0, then 42 minus 5B will be greater than 0. The value of B would be smaller than 42 by 5. So you can see that what we have is basically, if you have 4 into 8, so you can see that now the value of B can start with 1, 2, 3, and it will go till 8 because 5 into 8 is 40. These are the possible values of B, and corresponding to these values will have values of A. So number of elements or ordered pairs in this set R will be nothing but 8 ordered pairs. So value of m corresponding to this comes out to be 8. So once you have got this value, the next part says that now what you do summation from n is equal to 1 to 8 for this I 1 minus I raised to the power n factorial. You can see that there are two parts. One is 1 and another one is nothing but minus n factorial. So if I do it for the first part sign, it will be n is equal to 1 to 8 1 minus summation of n is equal to 1 to 8 I raised to the power n factorial. Now this is a constant, we are adding 1 8 times, so this will become 8, and this will become I raised to the power 1 factorial plus I raised to the power 2 factorial I raised to the power 8 factorial. If it is so, this will come out to be nothing but I, and this second part you can see that this will become I, so this will become minus 1. Then the next time it would be 6, so next term will also become minus 1. And then you can see that if I keep on moving, when I reach I raised to the power 4 factorial, that will become 1. And from there onwards to 8, it will all become 1. So if you write the values, what you are getting is this is 8, this is I, these two. Now you can see that there are 2 minus 1s. Now the total there were 8 elements. Out of those 8 elements, 1 is I. Out of those 7 elements, 2 are minus 1. So you can see that, and 5 are 1. So this will become minus 2 plus 5. If I simplify this, the value comes out to be nothing but 8 minus I plus 3, or it comes out to be 5 minus I. This is the answer that we are getting. So if you now carefully look into the question, what they are saying is the coefficient of the real part is nothing but x. So you can see that the value of x from here comes out to be 5. The imaginary part is nothing but minus 1, so that becomes the value of I. And m we figured out already 8. So what they are saying is you find the sum of all these and give me the final answer. So if I add these, it will be 8 plus 4, 12. So answer becomes 12 for this question. Let us check the options. You can see that A option matches.
The next problem type or type 2 problem is based on operations of complex number. So if I take two complex number and equate them, like x plus iy is equal to 2 plus 3i. So this can only happen when the real and imaginary parts are equal. So x is also known as a real part of z and y is also known as imaginary part of z. So in this case, it should become equal to 2 and this should become equal to 3. The next is we are talking about addition. This was the first concept. The next is addition. So if you add 2 plus 3i with 4 plus I, and if you add this complex numbers, the technique is very simple. You add the real part to real part and the imaginary part to imaginary part. So answer will become 6 plus 4i. The third question concept talks about nothing but subtraction. So if I take 2 plus 3i and subtract 4 plus I, again the same idea, you subtract the real part from real part and imaginary part from imaginary part. So answer becomes nothing but minus 2 plus 2i. Fourth idea is nothing but regarding multiplication. So again, if I take 2 plus 3i and multiply 4 plus I, so I'm going to multiply like we multiply two polynomials. So what we are going to do is we are going to apply distribution. So if I distribute, 2 will be first multiplied to 4 plus I and then 3i would be multiplied to 4 plus I. So if I do that, it becomes nothing but 8 plus 2i and this becomes nothing but 12i plus 3i square. And we know that I square is nothing but equal to minus 1. So it becomes minus 3. And now if you add it up, what you are getting is nothing but 5 plus 14i. So this is how you multiply two complex numbers. And the last or the fifth part is nothing but division. So if I have to divide 2 plus 3i by 4 plus I, what I'm going to do is I'm going to rationalize. So I'm going to multiply by 4 minus I in the numerator and denominator. So the sign of I you can change and then multiply. And if you do that, what you're getting in the numerator is again the multiplication of two complex numbers. So we can again distribute 2 into 4 minus I plus 3i into 4 minus I. And in the denominator, you can write it as 4 square minus I square. And since we know that I square is equal to minus 1, so if you simplify it is 8 minus 4i plus 12i minus 3i square. Then denominator it becomes 4 square plus 1. So the numerator, if you add everything up, it becomes nothing but 11 plus 8i. And denominator it becomes nothing but 17. So your answer becomes 11 by 17 plus 8 by 17i. Now let us look into this question that came into 2019. So this is a quite simple question based on equality of complex numbers, wherein the real part and imaginary part on both the sides needs to be equal. So in order to solve this question, we are going to first take LCM. So minus 2 into 3 times minus I by 3 whole cube will be equal to x plus IY by 27. And if I simplify this, this is nothing but minus 6 minus I whole cube by 3 cube is equal to x plus IY by 27. And if you further simplify this, this becomes nothing but minus 6 whole cube plus minus I cube plus 3 times minus 6 whole square into minus I, and then plus 3 times minus 6 into minus I whole square by 27, but that 27 we can cancel on both the sides, so it becomes nothing but equal to x plus I. So this is what we are getting. Now if we simplify it further, what I get on the left hand side is minus 216 minus I cube, and this will become nothing but minus 108 into I. Next term becomes nothing but minus 18 I square. This is equal to x plus IY. And now this is 216. This would become plus 18. So if I simplify, it becomes 198. This is minus I cube, so it will become plus I. This is 108I is equal to x plus IY. And if I do some very basic calculation, now you can see that it becomes minus 198 minus 107I is equal to x plus IY. So your x becomes nothing but minus 198 and y becomes nothing but minus 107. This much we are getting. Now if I subtract y minus x, it is nothing but 107 minus of that plus 198, that comes out to be 90. Now let us look into another problem that came into JEE Mains 2022. In this problem, you can see there is one part that is in the numerator, that is 1 plus 2i raised to the power 8. So I'm writing this as 1 plus 2i raised to the power 2 ka whole cube into 1 plus 2i whole square. So you can see that I have separated the 1 plus 2i raised to the power 8 into 6 plus 2, that is 8. And then if I take this another part, it is given as 1 minus 2i raised to the power 2. That is the reason I separated, because you can see that this number is getting multiplied with its conjugate. So it will become a square plus b square. So now, if I look into the denominator, it is again very interesting with 2 plus 3 plus 2i. And here if I take conjugate, 4 plus 6i. And now if I look into the numerator, 1 plus 2i whole square, it becomes 1 plus 4i square plus 4i raised to the power 3. And then if I combine the remaining two terms, it is 1 plus 4 raised to the power 2. And in denominator, you can see if I multiply, it becomes nothing but 12 plus 18i, then 8i minus 12. After doing this simplification, this becomes quite simple, because in numerator what we are getting is minus 3 plus 4i whole cube. And then this will become 25, 1 plus 4 whole square. And denominator, this 12 and 12 gets cancelled out and it becomes 26i. If I expand the cube, a plus b whole cube given in the numerator, it becomes nothing but a cube plus b cube plus 3a square b and plus 3ab square. Okay. And now this is quite simple to interpret, because all the terms here, we know what they mean and what they are equal to. But we will also have 25 by 26i along with it in multiplication. Now if I look into this, this is not very tough. What I can do is I can simplify. The first part becomes nothing but minus 27. The next becomes nothing but 4 into 4, 16, 64i. And then next is nothing but 9 into 3. So it is nothing but 12 into 9, that is 108i. And the next part becomes nothing but plus 3 into 3 into 4 square, that is nothing but 144. And along with that, we have again that 25 by 26i. Now, if you simplify this part, what we are going to get, this I is not in numerator but denominator, sorry. So once I simplify this, only I need to simplify this part, because here we have an I, this I will get cancelled out and we will get the real part as answer. Okay, if you want to simplify, you can simplify the whole, but I'm telling you what is going to happen. So if I just simplify this part, what we are getting is nothing but 44. So this would be something plus 44i. Now I'm not worried about this x, and this you can also adapt as a problem solving technique. Worry about the calculation of the relevant part, because what we want is a real part and that will get from here. And if you simplify this, it comes out to be 550 by 30. So D option is correct. Now let us look into this next question. And what we can do is we can put the value of z as nothing but x plus 10i, because they have given the imaginary part of z as 10. So once I do that, what is going to happen is nothing but 2 times x plus 10i minus n by twice of x plus 10i plus n will be equal to 2i minus 1. And now, if I do a little bit intelligent thing and take this 1 on the other side, so this will become 2x plus 20i minus n by 2x plus 20i plus n plus 1 is equal to 2i, and our calculation will become simplified because of this. Now if I take LCM here, it is 2x plus 20i minus n plus 2x plus 20i plus n divided by 2x plus 20i plus n is equal to 2i. So you can see that the n gets cancelled out. Once you have done that, we can move further. And now if I add the numerator up, what I am getting is nothing but 4x plus 40i. And if I multiply the denominator on the right hand side, it is 2i into twice of x 20i plus n. 2 we can cancel on both the sides. This becomes 2x plus 20i is nothing but 2x plus n into i and then plus 20i square. If I simplify this, what I'm getting is twice of x plus 20i. This is equal to nothing but minus of 20 plus 2x plus n. So you can see that the value of 2x comes out to be equal to minus 20 and therefore x becomes nothing but minus 10. So all the options giving us is the real part of z as minus 10 will become correct. So now you can see that either A or C can be the correct option. In order to find which one is further correct, we can compare the imaginary part, and if I do so, what we will get is 20 is equal to twice of x plus n. So 20 is equal to 2 into x, that was minus 10 plus n. So n becomes nothing but 40. So you can see from here our option C becomes correct. N is equal to 40 and x is equal to minus 10. Now let us look into the next question that was asked in JEE 2021. In this question, if I put the value of z as nothing but x plus iy, what I will get on my left hand side is x plus iy plus alpha times mod of x plus iy minus 1 plus 2i equal to 0. Now if I do this, what am I going to get is, if I separate the real part, it is going to be alpha. This x plus iy minus 1 can be written as mod of x minus 1 plus iy. And since it is a modulus, it is going to be a real value. So this is our real part. Plus y plus 2 into I. This is going to be imaginary part. So now, since it is equal to 0, we'll equate both the parts to 0. If I equate my imaginary part to 0, x plus 2 becomes 0. And that implies y is equal to minus 2. And further, for solving this, we'll put the real part also as 0. So x plus alpha times, I can interpret this modulus as root of x minus 1 whole square plus y square. This is equal to 0. If you further solve this, this can be written as x plus alpha times root of x minus 1 whole square. And since y is equal to minus 2, y square becomes 4 equal to 0. Now, in order to find the greatest and least value of alpha, what I can do here is, I can do some minor calculations. So I can take minus alpha root of x minus 1 whole square plus 4 on the right hand side and square both the sides. So this becomes x square alpha square, and inside this becomes x square minus 2 plus 5. If I simplify this, what I'm getting on the right hand side is alpha square minus 1 into x square minus 2 alpha square x and 5 alpha square equal to 0. Now once I've got this, this is the quadratic equation in x, and this equation is going to have real root only when the d or discriminant of this is greater than or equal to 0. If I apply this property, then b square minus 4ac, so here b is nothing but 2 alpha square minus 4a, that is alpha square minus 1, and c, that is 5 alpha square, should be greater than or equal to 0. Now if I simplify this part, I can take this 4 alpha square as common, and if I do so, what I'm left with is alpha square in the first term. In the next term, it will become nothing but 5 times alpha square minus 1 is greater than or equal to 0. And if I further simplify it, now this 4 alpha square will have no consequence. If I simplify the remaining part, it is minus 4 alpha square plus 5 is greater than or equal to 0. Or we can write this as alpha square minus 5 by 4 is smaller than or equal to 0. Sign has changed because we have multiplied by negative quantity on both the sides of inequality. So you can see that the value of alpha will belong to root 5 by 2 minus root 5 by 2 to root 5 by 2 in this duration. And once you have this, you have got the value of p and q. Your p is nothing but the least value to minus root 5 by 2, and q is nothing but root 5 by 2. What they're asking is p square plus q square into 4. If you put in these values, this becomes 4 times 5 by 4 plus 5 by 4, that comes out to be 10. Now let us move to the next problem type. This next problem type is the one that is based on properties of conjugate. Now, let us first look into what are the properties, what is the conjugate, what are the properties of conjugate, and then let us move into the problems that were based in JEE based on this idea. So, conjugate is a very simple idea. If we have 2 plus 3i, a conjugate will be represented by a bar, and that would mean 2 minus 3i. In terms of geometry, this means a reflection over the real axis. Now, if you look into the properties, if I do conjugate one more time, so we already had this value. If I do take conjugate one more time, you can see that I will get my original number, that is 2 plus 3i, and this is my first property. Second property talks about, and this is a very important idea, that if I add this number to its conjugate, so this imaginary part will get cancelled out and you will get 2 times the real part. And this is very important because sometimes the question will talk about purely imaginary numbers. So when we talk about purely imaginary numbers, then in those kind of numbers, the real part will become 0. So this z plus z bar equal to 0 will become the condition for z to be purely imaginary. And this is very important. A lot of JEE questions are based on this idea. Similarly, in the next one, what we are doing is we are taking 2 plus 3i and subtracting from this 2 minus 3i. Now you can see the real part will get cancelled out and we will get twice the imaginary part. And that is the reason that z minus z bar will be equal to 2 times imaginary part. And if I put z minus z bar equal to 0, that would mean imaginary part will become 0 and hence it becomes the condition for purely real. So these two conditions, something becoming purely real and purely imaginary, are very important conditions from JEE Mains point of view. Now, what we are doing next is we are talking about distribution of conjugate. So if I have addition, then also it gets distributed, subtraction, again distribution, multiplication, distribution, division, distribution. So you can distribute in practically all the scenarios. Also, if we have some raised to the power n, then also we can move it inside and outside. There is no problem. And rest of the properties are fine. But there are two important ideas I will try to once more illustrate. One is this z bar. So if I take z and multiply by z bar, I will take an example. So if I take 2 plus 3i and multiply by 2 minus 3i, so what will happen? This will become 2 square minus 3i square. So 2 square plus 3 square. And this is nothing but 4 plus 9, 13. So what is happening here is if I multiply this, what I ultimately get is x square plus y square, and that is nothing but mod of z whole square. Now, this is a very important property. It is not just a property, it is a route that we are going to take to maneuver through complex numbers. Because we will see that there will be very less properties in terms of modulus, but in terms of conjugate, we have got a lot of choices in distribution. So that we are going to utilize in solving problems. Now, this problem was asked in JEE 2022. This specifically targets on the idea of z plus z bar. You can see that what we have given this first term is z and then the z bar is given. We've already learned this property that if we have z plus z bar, it is nothing but 2 times real part of z. So this idea we need to use. Now here z is nothing but z is to the power 5. So that does not matter. We just need to get the value of z is to the power 5. So if I do z raised to the power 5, it is nothing but 2 plus 3i raised to the power 5. So whatever real part will get out of this, double of that would be our answer. So now let us look into this. So if I expand it using binomial expansion, what we will get is 5c0 2 raised to the power 5. Next term is 5c1 2 raised to the power 4 into 3i. Next term would be 5c2 2 raised to the power 3 3i whole square. Next term will become 5c3 2 raised to the power 2 and 3i raised to the power 3. The next would become 5c4 2 raised to the power 1 and 3i raised to the power 4 and 5c5 into 3i raised to the power 5. Now once you have this, you can just focus on those parts in this question which are real in nature. So this will be real, this would be real, and then this would be real. And the rest of them will contribute to the imaginary part. So if I look into the real part of z raised to the power 5, and it is nothing but 5c0 into 2 raised to the power 5. This I square we can put as minus sign. So 5c2 into 2 cube into 3 square. And the last part, that is nothing but 5c4 into 2 into 3 raised to the power 4. Okay, so this is what we have got so far. Now all we need to do is calculate this value and double it to get to the answer. So if I simplify the first part, it comes out to be 32. The next part would be nothing but 5 factorial by 3 factorial into 2 factorial. This 2 raised to the power 3 becomes 8, 3 square becomes 9. And this last part becomes 5c4 becomes 5 into 2, and 3 raised to the power 4 becomes 81. So this is 32 minus, this will become 10 into 72. This would become again 10 into 81. So if we simplify this, what we get is nothing but 32 minus nothing but 720 plus 810, and this is nothing but 32 minus 90 and 32 plus 90, and this becomes nothing but 122. And what we want is 2 times the real part of z raised to the power 5, and that becomes nothing but 240. Now let us look into this next problem that was asked in JEE Mains 2023. And in this problem, you can see that again they are targeting the same that I have emphasized while telling you the properties, that purely imaginary and purely real part. So what they are saying is this is purely imaginary. This would mean that if I do z plus z bar, it should be equal to 0. So we can use this idea. So if I take 1 plus 2i sine theta by 1 minus I sine theta, and if I add it with its bar, so 1 plus 2i sine theta by 1 minus I sine theta whole bar, this will be equal to 0. And if I simplify this, it is 1 plus 2i sine theta by 1 minus I sine theta, and this will become 1 minus 2i sine theta by 1 plus I sine theta. This will be equal to 0, and if I cross multiply, what I get is 1 plus 2i sine theta into 1 plus I sine theta plus 1 minus 2i sine theta into 1 minus I sine theta equal to 0. Now what I need to just do is simplify this. If I simplify this, what I get from the first part is nothing but 1 plus 3i sine theta minus 2 sine square theta, if I simplify the first part. And from the second part, if I do it, what I get is 1 minus 3i sine theta minus 2 sine square theta equal to 0. So if I'm simplifying both of these, this 3i sine theta would get cancelled out. And what we are getting ultimately is nothing but this expression that 1 minus 2 sine square theta, 2 times of this would be equal to 0. Or my sine square theta comes out to be equal to 1 by 2. That would mean sine theta can take 2 values. And either it can be equal to plus 1 by root 2, or it can be equal to nothing but minus 1 by root 2. If it takes the first value, that is plus 1 by root 2, in 0 to 2 pi, such possible values are pi by 4 and 3 pi by 4. So these are the principal values. Similarly, for the second one, if I find the values, it comes out to be 5 pi by 4 and 7 pi by 4. What they're saying is, what is the sum of all of these values? So if you add it up, it comes out to be equal to 4 pi. Hence our answer D is correct. Now this question can be done using one more technique. So instead of using z plus z bar equal to 0, what we could do is we can express this given complex number into x plus iy form. And since it is purely imaginary, then put the value of x equal to 0. Now this is a valid way of doing this question. So I'm going to also show you this technique. So what you can do is you can take this 1 plus 2y sine theta and 1 by 1 minus I sine theta and multiply with its conjugate. So 1 plus I sine theta. So this is what we do in division. The same technique that I told you for division, we are using it. If I simplify it, in the numerator, it will become 1 plus 3i sine theta minus 2 sine square theta. In the denominator, what we get is 1 plus sine square theta. Now we can see that the real part comes out to be 1 minus 2 sine square theta by 1 plus sine square theta. And the imaginary part becomes 3i sine theta by 1 plus sine square theta. You can see that since it is purely imaginary, the real part will be equal to 0. So this part should be equal to 0. So what we are getting is 1 minus 2 sine square theta by 1 plus sine square theta equal to 0. Now see, there is a word of caution here. Sometimes we'll directly write this as 1 minus 2 sine square theta equal to 0. And then we'll go and find the solutions. But also check that the denominator is not getting 0 for those solutions. Okay. So sometimes we will have to avoid those solutions for which the denominator will become 0. So after this, if I solve, the solution remains same. This becomes 1 by 2. So sine theta can have two possible values, 1 by root 2 and minus 1 by root 2. Corresponding to the first one, the answers are pi by 4 and 3 pi by 4. And corresponding to the second one, the answers are nothing but 5 pi by 4 and 7 pi by 4. If you add them, the answer still remains 4 pi. Now this next question is exactly like the previous question. Just it is on steroids. So it is the same question, but we have to do the same process twice. Let us see. So if I take my first complex number, they are saying that it is purely imaginary. So now, since I have already shown you using two methods how this question can be done, what you can easily identify is the second method is shorter method. So if I multiply and divide by its conjugate, that is 1 minus 2i sine alpha and 1 minus 2i sine alpha. What I get for the first complex number in the numerator is 1 minus 3i sine alpha plus minus 2 sine square alpha. And in the denominator, I'm going to get 1 plus 4 sine square alpha. So if I split it into real and imaginary parts, you can see that the real part is nothing but 1 minus 2 sine square alpha by 1 plus 4 sine square alpha. And then there is some real part, that is minus 3 sine alpha by 1 plus 4 sine square alpha. Now what they're telling us is this number is purely imaginary. That means this part needs to be 0. If this part becomes 0, then 1 minus 2 sine square alpha should be 0. That means sine alpha needs to be plus minus 1 by root 2. Now they are telling us that this alpha is there between pi to 2 pi. So plus 1 by root 2 value is not possible. Instead of this, the value that we need to consider is minus 1 by root 2. Corresponding to it, the values are nothing but 5 pi by 4. This is one of the value of alpha, and another value will be 7 pi by 4. Okay, so this process we have done in order to find the value of alpha. Now we have to do the same process one more time for beta. So let us look into that part of the process. So we will do the same thing, 1 plus I cos beta upon 1 minus 2i cos beta. Again, we can multiply by the conjugate to 1 plus 2i cos beta and 1 plus 2i cos beta. If we multiply and divide by the same quantity, what we are going to get here is nothing but, in the numerator we get 1 plus 3i cos beta minus 2 cos square beta, and in the denominator we have 1 plus cos square beta. So you can see that the real part comes out to be 1 minus 2 cos square beta by 1 plus 4 cos square beta, and the imaginary part comes out to be 3i cos beta by 1 plus 4 cos square beta. Now once you have written this, the important thing that we need to notice here is it is purely real. That means the imaginary part is 0. So this time this part will become 0. So if I put that equal to 0, the value of cos beta becomes 0. And from here, the value of beta between pi and 2 pi is nothing but 3 pi by 2. So before writing these values, we need to very carefully observe what is happening here. They are asking us values of alpha and beta between pi and 2 pi. So general values we do not need to consider. So from here, now let us go back to the question. Now this is not the question. Our question is slightly different. What they're asking in the question is all such complex numbers which are of this form. So now let us find the value of z alpha beta. So in one place, the alpha can be equal to 5 pi by 4 and beta has only one value 3 pi by 2. So one value of z alpha beta would become nothing but sine of 5 pi by 4 into 2 plus I times cos of 2 times 3 pi by 2. And if you simplify this, this is sine 5 pi by 2, that becomes 1, and that is cos 3 pi, that becomes minus. This you can simplify. Similarly, there is one more value that we need to find, and now this value will come when alpha becomes 7 pi by 4 and beta has only one value, that is 3 pi by 2. So if I find z alpha beta corresponding to this value, it is sine of 2 times 7 pi by 4 plus I times cos of 2 times 3 pi by 2. So again, if you simplify this value, what you get is minus 1 minus I. So we have got both the values. Now all we need to do is find this summation, and this is not very difficult to find. Let us find this summation. So in the final step, before finding summation, if you can simplify this quantity that is given to us. So let me write this quantity first. What we are given is z alpha beta plus 1 by I times z alpha beta bar. If I just take LCM, this would become I square z alpha beta z bar alpha beta plus 1. And denominator it is nothing but I z bar alpha beta. If I multiply by z alpha beta, something very interesting comes. And that is nothing. In the numerator, what we have is 1 minus mod of z alpha beta whole square. And in the denominator, we have I times mod of z alpha beta whole square. And in multiplication, what we have z alpha beta. We need to find the summation of all such values. So you can see that one value of z alpha beta was nothing but plus 1 minus I. And another one minus 1 minus I. If I put both of these values and simplify, so my answer or summation now will come out to be. And if I put these values, so let us put the first value 1 plus 1 minus I. If I put in the numerator, mod of this becomes divide by nothing but I into 2. And this value comes out to be 1 minus I. For the second one, if I calculate, it becomes 1 minus 2 by I into 2 into minus 1 minus I. If you simplify this comes out to be 1. Hence option C. So you can see that this question had three important parts. First, what we did in the earlier question, that we had to do purely imaginary, then purely real, second part. Then in third part, we had to find the value of alpha beta, z alpha beta. Those two values we got. And in the fourth part of the question, we had to find the summation that was given in the question. This was a very interesting question having three different parts, hence a little bit lengthy also. Now, again, this is a very interesting question asked in 2020. Question says that this equation has two roots which are conjugate complex numbers. So if I assume one to be z, another one would become z bar. Now they are saying that both of these satisfy this equation, so find the relationship between the. Very interesting question. So now what we can do is we can use this idea that zz bar is equal to mod of z whole square. This core property that we learned, we are going to use it in some form, not exactly like this, but some form. So now let us start with it. So now if these two roots are there for this equation, then we can write the sum of roots as minus b by a and the product of root as nothing but c by a. So these two ideas we have got. Next thing what they are saying is they satisfy this equation. So now modulus we cannot modify, but if I square both the sides, it will become 4 into 10. And this part I can write as z into z bar is equal to 40. Now if I simplify this, this is z plus 1 into z bar plus 1 is equal to 40. And if I multiply this, it is zz bar plus z bar plus 1 is equal to 40. Now we can put values here. So you can see that this value was nothing but minus b. So if I put here, it becomes nothing but this value becomes minus b plus 1. And the earlier one would become nothing but 45. So from here you can see that what we have is 46 minus b on the left hand side and 40 on the right hand side. So b clearly is equal to 6. Once we have found this value, now we need to satisfy the options and check which of the options is getting satisfied. So now if you take your option B and check, it is nothing but 6 square or b square minus b, to 6 square minus 6 would be nothing but 36 minus 6 comes out to be 30. You can see that your B option is getting satisfied.
It's the sum of all possible values for which this is purely imaginary. Lots of question has been asked on this idea of purely real and purely imaginary. So if you want to do this question, there are two ways to approach the question. One way would be we can simplify this into x plus iy form. And if it is saying purely imaginary, then put x equal to 0. If it is saying purely real, put y equal to 0. Another thing is if you have a complex number and if I take z and z bar, if somebody is saying it is purely imaginary, then z plus z bar should be equal to 0. In the case of purely real, what we have is z is equal to z bar. Now you can see that there are these two approaches. Sometimes first will work, sometimes second will work. In this question, let us check it out. In this question, let us check and see which approach work. So now in the first part, now what you can do is purely the sum of all possible values of theta such that this is purely imaginary. So what I will try and do is convert this into a x plus iy form. So I am using the first approach. So let me write it down. So it is 1 plus I cos theta by 1 minus 2i cos theta. We can multiply and divide by 1 plus 2i cos theta into 1 plus 2i cos theta. If I simplify, what are we going to get? In the numerator, it will become 1 plus 3I cos theta. And then what you are going to have is minus 2 cos square theta. If I do it in the denominator, you can see that this will become 1 plus 4 cos square theta. Once you have done it in this manner, now the next steps become easy. I can split it into two parts. One is imaginary part, one is real part. So 1 minus 2 cos square theta upon 1 plus 4 cos square theta. This will become the real part. And then you have I times 3 cos theta by 1 plus 4 cos square theta. Now when the question says that it is purely imaginary, that would mean this real part should be equal to 0. So in the next part, second, we are going to put 1 minus 2 cos square theta by 1 plus 4 cos square theta equal to 0. That will lead us to, so if I simplify this, 2 cos square theta minus 1 will be equal to 0. This is nothing but cos 2 theta is equal to 0. The graph will start from here, complete one cycle in pi, another cycle in pi. So you can see that this is how I will reach 2 pi. And then again another cycle till minus pi, this is minus pi. The question is saying that sum of all possible values of theta. Now when will it become 0? So you can see that half of this could be minus pi by 2. And this will become minus 3 pi by 4. This value will become minus pi by 4. Similarly, this value will become pi by 4. This will become 3 pi by 4. And now once you move pi ahead, it will be pi plus pi by 4 and then pi plus 3 pi by 4. Let us add all of these values and check. So if I add all of these values, these two values will get cancelled out. And what we are getting from here is pi plus pi 2 pi plus one more pi 3 pi. Let us check the options. So you can see that B option matches.
Now, next problem type is nothing but based on properties of argument. Let us quickly go into the properties of argument, then see what kind of questions are framed on it. So now, first, what is argument? So argument is nothing but tan inverse y by x. Now, there are two types of argument. One of it is known as principal argument. So when we say principal argument, it would mean the value of the argument should lie between minus pi to pi, where minus pi is open and pi is closed. When we talk about general argument, it can be any value that lies between real numbers. Now, if I have to find the value of principal argument, the logic is that you take, there are three steps. First, you determine the quadrant, in which quadrant the complex number lies. Second, find the value of theta, that is nothing but tan inverse mod of pi by x. And in the third step, based on the quadrant, you give the value of argument. So let us say that if it is in the first argument, then the answer would be theta. Second quadrant answer will be pi minus theta. Third one, minus pi plus theta, and 4 minus theta. So whatever value we are getting in third and fourth are nothing but negative value of the quadrant just above it. So if we have this, based on that, you can quickly give the answer. Let me take an example. So if I have to find the value of minus 1 minus I, the first thing that we are going to notice is what is the value of theta? That is nothing but tan inverse of mod of pi by x. So that becomes minus 1 by minus 1. So this becomes pi by 4. Now, once you have observed this, you have also observed the quadrant. So it is nothing. Since x is negative, y is negative, it is in the third quadrant. So our answer of argument of z would be nothing but the third quadrant, that is minus pi plus theta. So minus pi plus pi by 4, that is nothing but minus 3 pi by 4. So this is how we find it. The properties of complex numbers are not very difficult to remember. If you are multiplying two complex numbers, then their argument will get added up. If you are dividing two, it gets subtracted out. And if you are raising some power, then it gets multiplied into the complex numbers. So you can see that these are exactly like properties of log. So nothing very complex to remember. Just apply the properties of log and you will get the answer. Now, if you are applying the property in terms of general argument, then one more thing will come, that is this 2k pi. And this question has been directly asked in JEE Advanced exam one time. So it is a good idea to remember this basic idea. Now, apart from this, if you remember one more small thing, then your life will become even more simpler. So let us say that your complex number lies in first quadrant. So this is Z. So what we are saying is, if the argument in the first quadrant is nothing but theta, and if I take Z bar, so it goes in this quadrant. So if this angle was nothing but theta, then obviously this angle would become minus theta. And if I take minus of Z, then it will go here. So not minus Z bar, minus Z, it will go here. So now based on that, you can again understand what will be the answer in this case. And if you take minus of Z bar, then it goes in the second quadrant. So again, you can understand what is going to be the answer. So it is very simple if you look into this manner. But if you want to apply the properties also, from there also you can get the answer. Now let us jump into the first question. And you can very easily solve this question by properties of law. So this part you can easily write as argument of minus 1 into Z minus argument of Z. And now very easily you can apply the property, and multiplication of two complex numbers argument can be written as addition, exactly like we apply the property of log. This will get cancelled out, and what we are getting is argument of minus 1. If you can draw a very small diagram, you can observe that minus 1 lies here. So this angle is nothing but pi. So your answer becomes nothing but pi. Now let us look into this very simple next question that came into 2023. In this question, they have given the value of z and z1 in terms of z. So if I simplify z1, what I will get is, if I take LCM in the denominator, it becomes 1 plus I z bar into z by zz bar into 1 minus z plus 1. And if I open this bracket, this is z plus I zz bar by nothing but this will become mod of z whole square into 1 minus z plus 1. Now let us put the value. So it becomes 1 plus I in place of z. This becomes square. So mod of z is nothing but root 2. So mod of z whole square will become 2. This also becomes 2. This is 1 minus I plus 1. And if you do this very simple calculation, in the numerator what you are getting is 1 plus 3i. In the denominator what you are getting is 1 minus 2i after simplification. So if I rationalize by multiplying 1 plus 2i and 1 plus 2i numerator and denominator, what we get is nothing but 1 plus 5i minus 6 and denominator again 5. So your answer becomes nothing but minus 5 plus 5i by 5. It is nothing but minus 1 plus i. And if you take the argument of z1, it comes out to be nothing but 3 pi by 4. And if I multiply this by 12 by pi and find 12 by pi into argument of z1, it comes out to be nothing but 12 by pi into 3 pi by 4. And that would be nothing but equal to 9. Now let us look into this very simple and elegant question that came in JEE 2022. In this question, a relationship between z1 bar and z2 bar is given. And in fact, two relations are given and we have to comment on the argument of z1 and z2. So now if I take argument on this first statement, we can write argument of z1 bar as nothing but argument of I z2 bar. And using the properties, I can write this as argument of I plus argument of z2 bar. So it becomes argument of z1 bar. Argument of I becomes pi by 2. And then argument of z2 bar. This is my first equation. Another relation that they have given here also, if I apply the properties of argument like log, argument of z1 minus argument of z2 is nothing but pi. This is my second expression. And also if I do a little bit of manipulation before writing this equation, I can take this pi, I can take this argument of z2 on the other side. In fact, it is z2 bar, not z2. And it becomes pi plus argument of z2 bar. This is my second equation. Now what you can do is you can subtract from second equation first equation. If you do that, what you get on the right hand side is argument of z1 minus argument of z1 bar, and this would be equal to nothing but pi by 2. Now we knew that if argument of z1 is here, the bar would be here. So if this angle is theta, this is also theta. So if the argument of this is theta, then this will become nothing but minus theta. So what we can write is, if this is theta, this becomes minus theta. And this is pi by 2, twice of theta becomes pi by 2, or theta becomes pi by 4. So what we can say is argument of z1 or theta is nothing but pi by 4, that is option C. Now let us start this next question that was asked in 2021. So again, the question is very simple. They have given the value of omega. And they are again talking about another complex number z. And a relation between their arguments is also given. So now, if I find the argument of w, it would be nothing but minus of pi by 3. And we have talked about this multiple times. I can just observe and find. If you want to find, there was a method that we earlier discussed. If we want to find its modulus, it would be nothing but 2. And now simply what is given is relation between argument of z and w is given. So if I take argument of w on the other side, it is pi by 2 plus argument of w. And since this is nothing but minus pi by 3, argument of z becomes pi by 6. Also, there is a relationship between argument of w and z that their multiplication is equal to 1. So from here, if I want to find argument of z, it is nothing but 1 by argument of w. That is nothing but 1 by 2. So from this, we have two informations. One is that argument of w is equal to pi by minus pi by 3. This is one very important logic or information. And another one is, we talk about z, the modulus of z is nothing but 1 by 2. And argument of z is nothing but pi by 6. Now they are talking, after this information, about a triangle. That is, that if I draw an Argand plane, this is how it looks like. So one point is origin, and then another point is z. So if I draw z, it is going to be somewhere like this. The distance from origin is 1 by 2, this angle is 5 by 6. And if I talk about w, it is nothing but in the fourth quadrant, where this distance is 2 and this distance is nothing but, this angle is nothing but pi by 3. And now they are talking about this triangle OAB. Let us say this is O, this is A, this is B. And want to find the area of this. Now there is a very simple formula that area of triangle is nothing but half of multiplication of two sides and sine of angle between them. So if I apply this formula, OA is 1 by 2, OB is 2, and sine of angle between them is nothing but pi by 2. So if I do this, the answer becomes 1 by 2, and that is nothing but option 2. Now this next question is a very simple question asked in 2020. Looks like a complex question, but once you write it down, it is very simple. So if I take this z1 as a complex number x1 plus iy1, and if I consider z2 as a complex number x2 plus iy2. So now what this question is saying is, if you find real part of z1, that is nothing but x1, it would be equal to mod of z1 minus 1. So if I write it, is it x1 plus iy1 minus 1. So if I write x1, it is nothing but root of x1 minus 1 whole square plus y1 square. And if I square it, it becomes x1 square is equal to x1 minus 1 whole square plus y1 square. And if you simplify, this is x1 square, this becomes x1 square minus 2x1 plus 1 plus y1 square. x1 square cancels out. What we'll get is 2x1 minus 1 equal to y1 square. Now, if you look into second relation, it is exactly same relation. So if I simplify that also, instead of x2, x1 I will have to write x2, and instead of y1 I will have to write y2. So these are the two equations that I'm getting. This is first part of the problem. Now what they're saying is they've also given us argument of z1 minus z2. Now also let us also write this, what is z1 minus z2. So if I subtract z1 and z2, it is going to be a complex number x1 minus x2 plus I times y1 minus y2. So when they're talking about its argument, that would mean tan inverse of y1 minus y2 by x1 minus x2 would be equal to nothing but pi by 6. Or in other words, y1 minus y2 by x1 minus x2 is equal to tan of pi by 6, that is nothing but 1 by root 3. This becomes my second important relation. This is second important idea. Now, what we can observe here is what they're asking is imaginary part of z1 plus z2. Now, what is z1 plus z2? So if I add a z1 and z2, it is x1 plus x2 plus I times y1 plus y2. So this is nothing but the value of y1 plus y2. So for finding that, now we can use a very simple technique using this equation. So if I subtract from equation 1, equation 2, what I'm going to get is 2 times x1 minus x2 is nothing but y1 square minus y2 square. That if I simplify, can be written as 2 times x1 minus x2 is equal to y1 minus y2 into y1 plus y2. Now, if you look into this, the ratio of y1 plus y2 by x1 plus x2 we already know. So if I simplify this expression in this terms, 2 times x1 minus x2 by y1 minus y2, I will be able to get the value of y1 plus y2 that is asked in the question. Now this is simple to get. Why? Because this ratio I already know. If I put the value, this is 1 by root 3, or that is nothing but 2 root 3. So my option comes out to be D. Now let us move to our next problem type, that is properties of modulus. In this, first we are going to look into the properties of modulus and then what kind of problems are based on that. So if you look into the idea of modulus, it is nothing but mod of z is nothing but root of x square plus y square, and technically it is the distance of a point from origin. Okay, so this is a very important idea. Geometrically you should have imagination what does modulus of z means. Now since it is root of x square plus y square, it is obvious to say that mod of z is greater than equal to x and mod of z will always be greater than equal to y. So these are basic things. And obviously, since it is distance from origin, if I put a bar also, the distance is not going to change. And if I put a minus sign also, it is not going to change. And if I put both bar and negative sign, still it is not going to change. So from here, you can get some very simple properties. And if you look into the core concept of distance from origin. Now, if I look into the properties, one basic idea is obviously if it is distance, it needs to be greater than equal to 0. If we say mod of z is equal to 0, this would mean that real part and imaginary part of z are both 0 because the complex number itself has become 0. If I am saying modulus of z is greater than 0, this would mean that z cannot be equal to 0 because it has some distance from origin, so it cannot be equal to 0. Next is your real part of z. That is nothing but x will lie between mod of z and z. Next important property is, this we have already done when we did conjugate that, zz bar is equal to mod of z whole square, and this is very important route to take mod into the realm of conjugate, and from there apply the properties of conjugate and simplify it. Now we can see that if I talk about distribution of modulus, it works on multiplication and division but not on addition. So if I have z1 plus z2 mod, then in order to interpret this, I will have to use my resultant formula. That is nothing but root of, and you might have seen this in vectors, z1 square, z2 square plus 2 times z1 mod, z2 mod and cos of angle between them. This is a very important idea. Now, this can also be turned into an inequality that is known as triangle inequality. But now, JEE has categorically removed it out of the syllabus. So, I have also removed it from my teaching notes. I am not going to cover triangle inequality because it is categorically out of your JEE Mains syllabus. Also, you do not need to cover it for JEE Mains point of view. For JEE Advanced, you can cover it. Now, let us look into this 2019 question. It is again a very simple question based on very simple properties. What they are saying is a complex number z is given and its magnitude is also given. Then they are finding the value. They want us to find the value of nothing but z bar. So, interestingly, if the modulus is given and if I apply the condition based on my properties that I have learned, my modulus is going to be distributed in numerator and denominator. And since it is power, based on this property that mod of z raised to the power n is equal to mod of z raised to the power n, this square can be taken outside the mod sign. And in denominator also, it is 1 minus I mod. If I apply it in the numerator, it will become nothing but root 2 whole square. In the denominator, it becomes root of a square plus 1. Now, given this value is nothing but root of 2 by 5. If I simplify it and if I square both the sides, what I'm going to get is nothing but, this was 2. Again, if I square 2 square, this will become nothing but 2. The mod will get removed. Here it will become 5. And here in the denominator, it becomes a square plus 1. And if I simply simplify it, the value of a square plus 1 comes out to be 10. And hence a comes out to be equal to plus minus 3. Now, these are the values that I'm getting. Now, they are clearly given in the question that a is greater than 0. And from here, we do not need to consider the negative value of a, that is minus 3. So, a becomes nothing but plus 3. Now, once I've got this value, now from getting this value, I can write the value of z as nothing but 1 plus I whole square by a minus I. So, this came out to be 3 minus I. And numerator, if you simplify it, is 1 plus I square plus 2i. and I square is minus 1, so this part becomes 0. And this is 3 minus I. So the value of z is nothing but 2i by 3 minus I. And here if I take bar, that is what they want us to, it becomes minus 2i by 3 plus I. In order to divide it, I will multiply by 3 minus I in numerator and denominator. And if I do so, what I get in the numerator is minus 6i plus 2i square, and in denominator what we get is 3 square plus 1. And if I further simplify it, it becomes nothing but minus 2 minus 6i by 10, and this becomes minus 1 by 5 minus 3 by 5i. Now let us see which option matches. So you can see that your option B is getting matched up, and hence it becomes our answer. Now let us look into another question that came into 2021. And now this question, if you see, it is a combination of log and mod, primarily a question of mod only. So if I interpret this using properties of mod, you can see that the property of mod says that if you have log of x to a base that is between 0 and 1, and if you have to interpret this, so what will happen is we'll write x here, this sign will get flipped because this number is between 0 and 1, and this 1 by root 2 raised to the power 2 will come. Same logic we are using here, this sign will get flipped, it is 1 by root 2 raised to the power 2. So this becomes mod of z plus 11 by mod of z ka whole square minus 2 times mod of z plus 1, and this becomes greater than 1 by 2. If I take 2 on the other side, 2 times mod of z plus 22 is greater than equal to mod of z whole square minus 2 times mod of z plus 1. And if I simplify it, it becomes nothing but mod of z whole square minus 4 times mod of z minus 21 is smaller than equal to 0. If I simplify this, this comes out to be, after factorization, mod of z minus 7, mod of z plus 3 is smaller than equal to 0. Now if you look into this second part, this is always positive because sum of two positive quantities. So mod of z minus 7 is going to decide the sign. So mod of z, you can see, is smaller than equal to 7. So the largest value, or the largest value comes out to be 7. That is nothing but option 2. So primarily a question of log and some logic and some basic properties of modulus getting used. Now this very simple question came in 2022. This is primarily based on a very simple property of modulus. We'll see. So here what they're saying is this equation has two roots alpha and beta. So if I put alpha square should be equal to 1 minus 2i. And if I put beta, again beta square will be equal to 1 minus 2i. So I have kept this on one side and taken this on the other side. That's it. Nothing complicated I have done. So if I get these two alpha square beta square value, I can put it here. So this will become 1 minus 2i raised to the power 4. Second term will also become 1 minus 2i raised to the power 4 modulus. So it is mod of 2 times 1 minus 2i raised to the power 4. 2 I can take outside based on properties of mod. And we know that the very simple property z raised to the power n mod is equal to nothing but mod of z raised to the power n. This very simple property can be used here. What I can do is I can take this 1 minus 2i inside and 4 outside. So this becomes nothing but root 5 raised to the power 4. That is nothing but 2 into 25. That is nothing but 50. So option A becomes correct. Now let us look into this next question. Now these kind of questions have been asked in JEE. Now this 2022 question talks about a V, that is sum of 3 mods. So if I try and put the value of z is nothing but x plus I and open this first mod, then this becomes x square plus y square. The next one would become x minus 3 whole square plus y square. And the next one would become x square plus y minus 6 whole square. If I simplify this, this becomes x 3 times x square, 3 times y square. Then there would be minus 6x. Then there is going to be minus 12y. 1 3 squared, that is 9. And 1 36. If I simplify this, this is 3x square plus 3y square minus 6x minus 12y plus 45. Now what I can do is I can take these terms of x's and take 3 common. So this becomes x square minus 2x. Then take this y wala terms and take again 3 common. So y square minus 4y. And then you can see a 45 is left. Now I can make a perfect square out of both of them. And if I do so, it becomes x minus 1 whole square minus 3. This becomes y minus 2 whole square minus 12 plus 45. What you are getting is x minus 1 whole square into 3 plus 3 times y minus 2 whole square and then 10. What they're talking about is what is the minimum value of v. You can see that this perfect square we have formed in order to get the minimum value only. So this becomes 0, this becomes 0. The minimum value is going to be 30. So from here we get the value of x, that is nothing but equal to 1. The value of y, that is nothing but equal to 2. And the value of v0, that will be equal to 30. Corresponding to this, the z comes out to be 1 plus 2y. Now this is very important because the next part of this question is based on this only. Now we have to put these values, simplify and get the value of the last term that they're talking about. So you can see that there are multiple ingredients into it. First one is z0 square. So if I take 1 plus 2y and do a square, this will become 1 minus 4 plus 4i, that is minus 3 plus 4i. This is the first part. Another part is z not bar and then cube. So if I put bar, it is 1 minus 2i then whole cube. Now if I apply a formula a cube then plus b cube plus 3a square b plus 3a and b square. If I have to again simplify this, so this will become 1 and minus 8i cube minus 6i and then finally 12i square. And if I again simplify this, what you can see is basically we are getting plus 8i. So this becomes nothing but minus 11 plus 2i. The expression that was given to us was nothing but 2 times z0 square. So z0 square we have already figured out as minus 3 plus 4i. So if I multiply by 2, it becomes minus 6 plus 8i. Then it talks about minus z0 bar cube. So that is minus 11 plus 2i. And then finally up 3 added, then square of this plus v0 square, that is 30 square. If I simplify this, what you are getting inside mod is nothing but, after simplification, it will become nothing but 11 minus 6 plus 3, that would become nothing but 8, and then plus 6i, okay, mod ka whole square plus 900, and that comes out to be 1000. And that matches our option A. You can see that the question had two parts. One is this perfect square generation and getting the minimum value of v, that is v0, and then after that it is all calculation, do the calculation, get the answer. Now let us look into this 2020 question. It is a very simple question. If you plot it on a Argand plane, so let us consider z as in the first quadrant and x plus iy. So on Argand plane, if I convert this question into coordinate geometry, so see, this one phenomena you should always understand, and it's a very useful thing, that what we are writing as 1 plus 2i on Argand plane is equivalent to writing 1 comma 2 on a coordinate plane and is equivalent to writing I cap plus 2j cap in terms of vectors. Now this interconnection between the idea of complex numbers, coordinate geometry and vectors is very important, because time and time again we'll use this logic to solve questions very fast. Like in this case, if I consider this as z or x comma y, then this will become x comma minus y, because z bar is nothing but x minus iy. So using this basic logic to solve the question is very important. So what they are doing is, now in order to get another point, we are subtracting 2 times real part of z. So this will become a complex number x plus iy minus 2 times x. You can see that it is minus x plus 2 iy plus iy. So this point becomes minus x comma y. Similarly, this will become minus x comma minus y. So one side of this square you can see comes out to be 2 times y and another comes out to be 2 times x. Now they have given the side as 4. So twice of x is equal to 4 and also 2y is equal to 4. So you can see the value of x and y both comes out to be 2. If I want to find mod of z, it is nothing but root of x square plus y square, or nothing but root of 4 plus 4, that is nothing but 2 root. Hence option C becomes the correct answer. So very simple to do. If you are able to connect these three ideas, which time and time again will become very important in complex number. Now this next 2020 question again explores the same connection between coordinate geometry and complex numbers. So if I take z as nothing but x plus iy, the real part of z is nothing but x. So this equation that is written is nothing but mod of x plus mod of y is equal to 4. Now you can this graph you should already know. But let us say if you do not know how we are going to do. If I take both the x and y in first quadrant, then this will become x plus y is equal to 4. That would mean in first quadrant, if I try and draw the graph, this is how the graph looks like. Similarly, in the second quadrant, if I take, that means x is smaller than 0, y is greater than 0. This modulus for x will open with a negative sign, and this is how it will look like. And here, if I draw it now, in the second quadrant, this is the line that we get. Similarly, in the third quadrant, that is x and y are both negative, the line, this equation will become minus x minus y is equal to 4, and it will become a line like this. And in the fourth quadrant, when x is greater than 0, but y is smaller than 0, if I consider this, it will become x minus y is equal to 4. And if I interpret it, this is how it is going to look like. So if I draw all of these graphs on one graph, this is a square that looks like this. For this square, this point is 4, this is 4, this is minus 4, this is minus 4. So now the distance from origin is nothing but modulus. So what can be the possible values of modulus? So the maximum distance that is possible is this distance from here to here. And the minimum distance that is possible is this distance from here to here. Now this is the midpoint of this line. So it is bound to be 2, 2. So now you can see the maximum distance or the maximum value of modulus is nothing but 4. So it needs to be smaller than or equal to 4. And the minimum value of z, so it needs to be greater than or equal to root of 2 square plus 2 square. That is nothing but needs to be greater than or equal to 8. So you can see that only those values of modulus are valid that are between root 8 and 4, that is nothing but root 16. So you can see your A option, B option cannot be correct for this because they are talking about this cannot be. So cannot be is something root 7. So this cannot be your answer. Now let us look into this next problem type that is based on algebraic form. Now complex number can be expressed into 3 different forms. The first one is algebraic form where we can write z is nothing but x plus iy. We can also express this on the eigen plane as x comma y, which is equivalent to x comma y on coordinate plane, and x cap plus y j cap in vectors. So we are going to use this idea to solve problems. Now this problem was asked in 2019, and you can see that they are asking us to find the value of modulus of z. Now these kind of questions are based on equations that can be solved using putting z equal to x plus y. Now there can be multiple ways. I am using the method that according to me is one of the best methods of solving all equation based questions, right? So here if you put the value of z is nothing but x plus iy, your mod of z can be substituted as root of x square plus y square, and mod of z is always real. So this is going to help us in solving the problem. So root of x square plus y square plus x plus iy is equal to 3 plus I. You can see that the real part on this side is this much. So root of x square plus y square plus x would be equal to 3 and y will be equal to 1. So once you have got this value, you can put this value of y in first equation. So this becomes root of x square plus 1 is equal to 3 minus x. Let us square both the sides. If I do so, it becomes x square plus 1 is equal to x minus 3 whole square, or x square minus 6x plus 9. And if I simplify this, what I'm getting is minus 6x plus 9 is equal to 1, or 6x would be equal to 8. That implies x is going to be 4 by 3. Now once I have got this value as x is 4 by 3, y we already knew was equal to 1. I can get the value of modulus by substituting this value. So this becomes 4 by 3 whole square plus 1 square. That would be equal to root of 16 by 9 plus 1. That will become 5 by 3. So you can see our B option becomes correct. Now let us look into this next question that came into 2020. Again, what we will do here is put z is equal to x plus iy. And it is again an equation based question. So if I do so, x plus iy whole square would be equal to I times root of x square plus y square whole square. If I simplify, it is x square minus y square plus 2x xyi. Now we have done this multiple times, so I hope this you should remember. I into x square plus y square. Now compare real part with real part. So x square minus y square become equal to 0. And 2xy come out to be equal to x square plus y square. Now from here, we can get two values. One is y is equal to x, or we can get y is equal to minus x. Corresponding to this, if I satisfy, this is my case 1. If I satisfy in this equation, then this becomes 2 times x square is equal to x square plus x square. And you can see that it is satisfying it. So twice of x square will be equal to twice of y square. And this is satisfying. Wherein if I take this, it becomes minus 2x square is equal to x square plus x square. It does not satisfy. So from here, we can say that y is equal to x is our answer. That is option A. Now let us look into another question that was asked in 2022. Now you can see that it is almost same question, just that the summation concept they have added one more layer into it. So if I put it here, then x plus iy whole square plus x minus iy will be equal to 0. If I simplify, x square minus y square plus 2xyi plus x minus iy will be equal to 0. If I look into my real part and imaginary part, it becomes x square minus y square plus x equal to 0. This is my first equation. And simultaneously, y's of xy minus y should also be equal to 0. So now you can see that the second one is more simpler to solve. So from this, we will get our two cases. The first one is y equal to 0. Or we can have nothing but y's of x minus 1 equal to 0, or x is nothing but equal to 1 by 2. Now consider these two separate cases. And in each of these cases, let us try and get the value of the first one. If I put y equal to 0, this is my case 1. You can see that corresponding to y equal to 0, x square plus x will be equal to 0. And we are getting two values of x equal to 0 and x equal to minus 1. Fine. Now once we have done that, this is my case 1. Corresponding to case 2, that is nothing but x is equal to 1 by 2. If I put it in this equation, it will become 1 by 4 minus y square plus 1 by 2 equal to 0. So y square is equal to 3 by 4, or y is equal to correspondingly plus minus root 3 by 2. So now let us see how many answers that we got. So the first case was when we got x equal to 0 and y is equal to 0. Corresponding to this, the complex number would be 0. Another case was if I put x equal to minus 1 and y is equal to 0. Corresponding to this, the complex number would be minus 1. Now these were from the first two cases. The second case is nothing but x is equal to minus 1 by 2 and y is equal to root 3 by 2. Corresponding to this, the complex number is minus 1 by 2 plus I times root 3 by 2. And the last one is x equal to minus 1 by 2 and y is equal to minus root 3 by 2. That is nothing but minus 1 by 2 minus I root 3. Now let us look into the question once more. What the question is asking is, if you add all the real parts and imaginary parts, what is going to be the answer? So what they're saying is basically, take all the real parts. So if I look into all the real parts, that will come out to be 0, minus 1 by minus 1. And then in the second part, sorry, it was plus 1 by 2. Minor correction, sorry. So it becomes this. If I add 0, all the real parts, plus 1 by 2, plus 1 by 2. And then all the imaginary parts. If I add all the imaginary parts, it is nothing but root 3 by 2 minus root 3 by 2. You can see that this also adds up to 0. This also adds up to 0. So answer to this question is nothing but 0. The next question that we are going to do is based on JEE Mains 2023. Now, if I look into this question, what you can do is you can just put z is equal to x plus iy. If I do so, my left hand side becomes x minus iy, I into x plus iy whole square plus real part of z bar is nothing but x only. Now, if I simplify a bit and compare real and imaginary part, what I will get is I into x square minus y square plus 2xyi plus x. So, if I simplify one more step, the imaginary part is x square minus y square plus x, and the real part is minus 2xy. So if I compare the real part, I get my first equation. From here, if I simplify, I am getting two values, x is equal to 0 or y is equal to minus 1 by 2. If I look into another equation, it is x square minus y square plus x equal to minus y. Now, corresponding to the first case, that is x equal to 0, let us see what are the values that we can get. So if I put x equal to 0 into this, what I get is minus y square equal to minus y. Minus I can cancel out. So there are two values of y equal to 0 and y equal to 1. This is 1. Another case 2 that we can consider is y is equal to minus 1 by 2. If I put it here, it becomes x square minus 1 by 4 plus x plus 1 by 2. And if I bring it on the left hand side, it becomes x square plus x minus 3 by 4 equal to 0. And you can solve this to get the value of x. So minus 1 plus minus root of b square minus 4ac by 2a. So if I simplify, minus 1 plus minus, and this will become 2 by 2. So if I take plus sign, what I get is nothing but minus 1 plus 2 by 2, that is 1 by 2. And if I take the minus sign, it is minus 3 by 2. So corresponding to this, now let us write all the possible values of z that we are getting. So if I write all the possible values of z, the first value of z that we got was x equal to 0 and y equal to 0. So z becomes 0. So corresponding to this, mod of z also becomes 0, and corresponding to this, mod of z whole square also becomes 0. The second case was the value of z comes out to be I or 0 plus I. Mod of z becomes 1 and mod of z ka whole square also becomes 1. In the next case, the z was nothing but 1 by 2 minus 1 by 2i. 1 by 2 minus 1 by 2i. And if I correspondingly calculate mod of z, it is nothing but root 2 by 2. So mod of z ka whole square becomes nothing but 1 by 2. And the last value that we got for z was nothing but minus 3 by 2 minus 1 by 2i. Mod of z in this case comes out to be root of 9 by 4 plus 1 by 4, which will translate into mod of z is equal to 5 by 2. And now mod of z whole square. So now if I find the value of all the mod of z squares, if I add them, so it becomes 0 plus 1 plus 1 by 2 plus 5 by 2. If you add them, this comes out to be. Now let us look into this next question that was asked in JEE Mains 2023. In this question, what they're saying is, if I take my z as x plus I by, so the value of x they have already given is 3. So this is what is given in the question. They have given a complex number, that is z minus z bar plus zz bar divided by 2 minus 3z plus 5z bar. And in this question, what they're saying is the real part of this, whatever it comes, the range is alpha comma beta. Then find the value of the answer. So if you look into this question, there are three parts. First is, we need to figure out the real part of this new complex number. Let us say z1 they have given to us. Second, you need to find the range of z1. And in the third part, you get to the answer. So there are three steps in solving this question. So let us do all the steps one by one. Now this real part we have already figured out using expressing into the standard form of a plus iv. So it's exactly that we are going to do. So if I put z is nothing but 3 plus iy, and z bar will become 3 minus iy. Zz bar will become mod of z whole square, so 9 plus y square. And in the denominator, what I can write is nothing but 2 minus 3 times 3 plus iy plus 5 times z bar, that is 3 minus iy. If I simplify this, the numerator would become nothing but 9 plus y square plus 2iy, and denominator, if you simplify, what you get is 8 minus 8iy. Once you have this, and it is very simple, because now if I look into my numerator, it is 9 plus y square plus 2iy, and denominator I can take the 8 common and it becomes 1 minus iy. So in order to get the real part, I will multiply by 1 plus iy numerator and denominator and simplify. If I do this, what I get in the numerator in the real part is 9 plus y square. And then what I will get as the imaginary part, the other part would be when this and this gets multiplied. So that would be minus 2y square. Next part would be minus 1 into some imaginary part. We do not need to calculate it because it is not relevant to the question that is asked. In denominator, what we get is 8 times 1 plus y square. So now the question is plain and simple, that you find the range of this part. So we have already done the state or the first step of the question. Now let us move towards the next part of the question. So if I take this as real part, so 9 plus y square minus 2y square can be written as nothing but 9 minus y square by 8 times 1 plus y square. What I need to do is I need to find the range of this function. And in order to find range, there are multiple techniques that you can use. In fact, there is a clear-cut technique in quadratic equation in order to find this range. If you have not gone to the quadratic video, you can go and refer back to that video. But the logic is very simple in this case. What we are going to do is, in order to find this answer, we are going to reduce down. Now, this technique, what I am telling you, we learn in function. So this is our part 2 of the question. Part 1 of the question we have already done. In order to get this answer, first let us simplify this. So if I simplify, this can be written as 10 minus 1 plus y square by 1 plus y square into 8, the denominator. And this is nothing but a very simple expression that would become 10 1 by 8 times 10 by 1 plus y square minus 1. Now, why is this relevant and important? Because now what we are going to do is we are going to break it down. So in order to get the range of this function, let us find the range of this function. 10 by 1 plus y square minus 1. And in order to get this, let us find the range of 10 upon 1 plus y square. In order to get the answer of this, let us find the range of 1 upon 1 plus y square. In order to get the answer of this, let us find the answer of 1 plus y square. And for this, what we require is y square. Now, y square, you know, and is greater than or equal to 0. So if I add 1, it will be greater than or equal to 1. That is 1 to infinity. If I take reciprocal, 1 by infinity becomes 0. 1 by 1 becomes 1. If I multiply by 10, this becomes 0 to 10. If you subtract minus 1 to 9. And now, if I divide by 8, so the answer of the question or the part that is relevant to us comes out to be nothing but minus 1 by 8 to 9 by 8. This is what is relevant. And why is this relevant? Now, this is relevant because from here we can get the value of alpha and beta. Now, if you look into the question, your alpha will come out to be minus 1 by 8 and your beta will come out to be 9 by 8. If you put in the expression that is given to us, that is 24 times beta minus alpha, what you get is 30. So your answer becomes nothing but D option. Now, if I look into this next 2023 question, it has 3 parts in the question. The first part talks about solving an equation. Now, once the solving an equation part comes out into picture, it is obvious to put z is x plus iy. Here they have given the value, so we will put alpha plus I beta. So this is the first part of the question, to solve this equation and find the value of alpha beta. And the second part says that you form a quadratic equation which has roots alpha plus beta and alpha beta. You need to be very careful, otherwise the answer can go wrong very soon. So let us start with the first part. So if I put this value alpha plus I beta plus 2 ka mod is equal to alpha plus I beta plus 4 plus 4i. Now if I take the real and imaginary parts together, the left hand side becomes alpha plus 2 whole square plus beta square, and right hand side becomes alpha plus 4 plus beta plus 4 times I. Now, if you carefully observe and compare the parts, real and imaginary parts on both the sides, the value of beta plus 4 is 0. That implies beta comes out to be minus 4. So the first important thing we have already figured out. For finding alpha, we need to compare the real part. and that is nothing but alpha plus 2 whole square, and beta, if I put it here, will become 16, will be equal to alpha plus 4. If I square both the sides, it becomes alpha plus 2 whole square plus 16 is equal to alpha plus 4 whole square. So this becomes alpha square plus 4 alpha plus 4 plus 16. This is alpha square plus 8 alpha plus 16. So 16 cancels out. Alpha square will also get cancelled out. And you can see that 4 alpha will be equal to 4 alpha comes out to be 1. So you can see that by finding alpha is equal to 1 and beta is equal to minus 4, we have done with the first part. Now the second part, usually in JEE Mains question, they will combine two different problem types from two different chapters. So the second part of the question comes from quadratic equation, which talks about formation of quadratic equation. So we have a formula there for forming quadratic equation, and then formula goes like this: x square minus sum of roots into x plus product of roots equal to 0. So for this, we'll have to find sum and product of roots. Now you can see that the first root is alpha plus beta. So if I add alpha plus beta, I will get my first root. So my first root comes out to be nothing but minus 3. And for finding another root, alpha into beta, if I do, it comes out to be nothing but minus 4. Now I have figured out my roots, so I will have to find their sum. So if I find my sum, it is nothing but minus 7. And if I find the product, it is nothing but 12. Now, in order to form the quadratic equation, x square minus sum of roots into x plus product of roots equal to 0. So if I simplify this, you can see your D option will match. Now this next question is quite simple question. What they are saying is, they have given a complex number and they are saying the real part is equal to A. In the second one, the real part is equal to B. You can see that what they have done is they have interchanged the value of A and B, and also it is given that A and B are real number and A is not equal to B. Having given these three conditions, let us write the real part of az square plus bz. So if I write z square becomes x square minus y square plus 2xy. Now we have done this quite some time. And b into x plus iy is equal to a. So if I compare the real part, what I get is a times x square minus y square plus bx is equal to a. And all I need to do is interchange the values of a and b, and that is what has been done in the second part. So becomes b times x square minus y square plus ax is equal to b. Now what we can do is we can subtract these two equations. Why are we doing so? You will understand in a minute. So if I subtract this, it becomes a minus b into x square minus y square plus b minus a into x is equal to a minus b. Since a is not equal to b, I can cancel a minus b from both the sides. And if I do so, it becomes x square minus y square minus x is equal to 1. And you can see that if you simplify a little bit, you will see that there are multiple values, in fact infinite values, that can be substituted in this equation, and hence the answer becomes infinite. Now let us look into this next question of 2023. This question does nothing but plays on your confidence. So if you write what they are asking in the question, so let us say that a is also a complex number. So let us write this as a1 plus iota a2. Once you have done that, and let us also write z as nothing but x1 x plus iy. So if I do that, what you will observe here is, let us write the real part of a plus z bar. So a plus z bar would be nothing but a1 plus I a2 plus x minus iy. So you can see that the real part of a plus z bar is nothing but a1 plus x. Similarly, if I write nothing but a bar plus z, it is nothing but a1 minus I a2 plus x plus iy. And if I find the imaginary part of nothing but a bar plus z, it is nothing but, you can see from here, can be written as y minus a2 or minus a2 plus y. Now for the set A, the condition that they have given is, whatever we are writing in the first part, that is a1 plus x, needs to be greater than y minus a2. So you can see that from here a1 plus a2 needs to be greater than y minus x. In the B part also they have given the same conditions. The sign has been interchanged. So a1 plus x needs to be smaller than y minus a2. So a1 plus a2 is smaller than y minus x. What they're saying is they have given two more conditions to us, statements to us. What they're saying is real part of A and imaginary part of A both are greater than 0. So if real part of A and imaginary part of A, that is A1. So in the statement 1, what they're saying is A1 and A2 both are greater than 0 because they have put a comma sign between them. They both are positive. In that would only mean from A set that y minus x is smaller than 0. Similarly, if I look into my statement 2, what they're saying is that A1 and A2 are both negative. If A1 and A2 are both negative, then A1 plus A2 will also be smaller than 0. So if it is negative number, then what we can say is y minus x can be greater than 0. So y is greater than x. Now this is also a region. This is the region above the line that I earlier drew. This statement is also false and hence option A becomes correct. Now this question that came in 2023 is extremely easy question. In this, if I assume my z1 is nothing but x1 plus I by 1 and z2 is nothing but x2 plus I by 2, and if I multiply z1 z2, what you are going to get is x1 x2 minus y1 by 2 plus I times x1 by 2 plus x2 y1. I guess this is very familiar thing that we all know. Now what they're saying is the real part is equal to 0. That means this part will be equal to 0. So x1 x2 will be equal to y1 by 2. And in the next condition, what they're saying is the z1 plus z2 real part, that will be x1 plus x2. This is also 0. This is my next condition. So if you check out this condition from here, x1 and x2 are going to have opposite signs. So x1 is equal to minus of x2. Once you observe that, if x2 is positive, x1 will become negative, so on and so forth. Now, if I put x1 and x2 here in form of x1 only, it becomes nothing but. So here if I substitute the value of x1 in the first expression, it becomes minus of x2 square is equal to y1 by 2. That means y1 into y2 is smaller than 0. And that would mean y1 and y2 is opposite signs. Now if you look into option A, they are saying they have same signs. Option D, same sign. But if you look into option B and C, what they talk about is they have opposite signs. Hence option B and C become the correct answer. Now let us look into this another question that came in 2023. In this question, if you put in place of z nothing but x plus iy, this question becomes a very simple question. Why? Because the left hand side will become x minus iy. Z square we have found it multiple times, x square minus y square plus 2xyi. Now if you compare the real and imaginary part, you can see that it can be written as minus 2xy plus I times x square minus y square. So if you compare real part, x is equal to minus 2xy. If I solve it, there are two solutions that we are getting, x equal to 0 or y is equal to nothing but minus 1 by 2. If I compare my imaginary part, what I am getting is minus y is equal to x square minus y square. So if I take x equal to 0 as my first case, what are the answers that I am getting? So minus y will be equal to minus y square. Correspondingly, either you will get y is equal to 0 or y is equal to 1. Now, if I take another value, that is y is equal to minus 1 by 2 and simplify, let us see what we get. If I put it, the left hand side becomes 1 by 2, x square minus 1 by 4. X square is equal to 3 by 4 or x is equal to plus minus root 3 by 2. Now let us look into the answers that we have got. One answer that we have got is nothing but I. Another one is 0. Then there is plus root 3 by 2 minus I by 2. And then there is minus root 3 by 2 minus I by 2. Now the question very clearly says that the vertices are non-real roots. That means we need to neglect the 0 and consider the other roots. Now here comes a very interesting part that you can use in most of the questions involving complex numbers and geometries. You can convert this question into a question of coordinate geometry. So what we could do here is basically corresponding to I, a point on coordinate plane will be nothing but 0, 1. Corresponding to this second point, a point can be root 3 by 2, minus 1 by 2. Corresponding to last one, the answer is nothing but minus root 3 by 2 minus 1 by 2. And now, since we know these three roots, we have a formula for finding the area of a triangle when three roots are known. That formula goes like this: 1 by 2 times mod of x1 y1 1, x2 y2 1, x3 y3 1. So all we need to do is we need to substitute these values. So if I do so, it becomes 1 by 2 times determinant of 0 1 1 root 3 by 2 minus 1 by 2 1 and minus root 3 by 2 minus 1 by 2 1. And if we simplify this, the answer that we get is nothing but 3 root 3 by 4. And because we also need to consider modular sign of this. You can see our A option matches. Now, in this question, you might have seen a very unique thing that we did. We converted a question of complex number into coordinate geometry and we solved it. So this linkage between complex number, coordinate geometry, and vectors is very important that we are going to time and time again use in questions involving geometry. Now let us go into type 7 problem type, that is trigonometric and exponential form based questions. Now for a complex number, as a layman we should know that there are three forms. First one is algebraic form, or z is equal to x plus I by. Another one is z is equal to r times cos theta plus I sin theta. This is nothing but the polar or trigonometric form. And the third one is r e raised to the power I theta. Here respectively the value of r is nothing but modulus of z, and the value of theta is nothing but argument of z. A very important idea based on this logic is nothing but de Moivre's theorem, and this theorem is very simple. So if I write e raised to the power I theta, it will be nothing but cos theta plus I sin theta. So if I write e raised to the power I n theta, on the right hand side we can write this as cos theta plus I sin theta raised to the power n. But if I just replace theta with n theta in the first one, I will get my left hand side, that is cos raised to the power n theta plus I sin n theta. Now this theorem that I have written here is known as de Moivre's theorem. Generally while applying this theorem, we will apply this theorem, but more generally we will apply the exponential form from where the theorem comes. So let us jump into the problems based on this idea. Now let us start our discussion with first problem that came in 2020. Now this is a very simple problem. Now my technique is to use less properties and more these forms and directly get answers from there. So let us see how this technique works out. So what we can do is this part that is written in the numerator, we can convert this into its exponential form. So it will be r here comes out to be 2, and the argument, since it is in the second quadrant, comes out to be 2 pi by 3. The second one, that is denominator 1 minus I, if you find r, it is root 2, and argument in this case is nothing but minus pi by 4. If I divide this, what will happen is 2 e raised to the power I 2 pi by 3 divided by root 2 e raised to the power minus I pi by 4. This will get divided, and then there is 30 in the power. So it becomes root 2 into e raised to the power 2 pi by 3 plus pi by 4 into 30, and this 30 will also come in the power of root 2. Now in the next step we can directly multiply 30 inside. So if I do so, what I get is nothing but 10 pi, and here it will become 15 pi by 2. Now interestingly, if I further simplify it, this can be written as nothing but 16 pi, 6 we have borrowed from this 15 pi by 2 plus 3 pi by 2 into b. Now if I split into two parts, and this you should generally know that e raised to the power I 2 pi or any multiple of 2 pi will be equal to 1. This is very simple. You can do it from polar form and can also observe. So you can see that this part, when you will write separately, I will write and show as well, e raised to the power I into 16 pi and e raised to the power I 3 pi by 2. Now this part that we have written here will become nothing but 1. And the second part will become nothing but minus I. So your answer becomes minus I 2 raised to the power 15, and that is nothing but option A. Now let us look into next question that also came on the same idea. And here there is a minor simplification that we are going to do. And I will also tell you a shortcut that works on all such questions. So what you can do is, see, what we know is this formula of 1 plus cos theta. That is nothing but 2 cos square theta by 2. And 1 minus cos theta, that is nothing but 2 sin square theta by 2. Problem here is that instead of that we have 1 plus sin theta. So what we are going to do is we are going to convert sin theta into cos theta by applying cos theta is nothing but sine of pi by 2 minus theta. If I use this logic, if I have sine 2 pi by 9, I can write this as cos of pi by 2 minus 2 pi by 9. And which in turn can be written as cos of, if I simplify whatever is inside, it will become cos of 5 pi by 18. Once you have done that, interestingly, we can rewrite this statement into the question into 1 plus cos 5 pi by 18 plus I times sin pi by 18, 5 pi by 18. And in denominator 1 plus cos of 5 pi by 18 minus I sin 5 pi by 18. And now you can observe what I will do here. And this is something very general that we will use multiple times in multiple questions. So now 1 plus cos theta can be written as 2 cos square theta by 2. So this becomes 5 pi by 36. Here also sin 2 theta can be written as 2 sin theta by 2. That is 5 pi by 36 into cos of 5 pi by 36. In the denominator, same thing. 2 cos square 5 pi by 36 minus I times 2 sin 5 pi by 36 and 2 cos 5 pi by 36. And you can see now that on this power we have 3. What will happen after this? Now you can see that this part, that is 2, get cancelled out. Also you can see that this cos terms will also get cancelled out. So what we are getting after this simplification in the numerator is nothing but cos of 5 pi by 36 plus I sin 5 pi by 36, and in denominator what we are getting is cos 5 pi by 36 minus I sin 5 pi by 36 raised to the power 3. So now what you can do is the numerator part we can write as I raised to the power 5 pi by 36. Denominator becomes e raised to the power minus I 5 pi by 36 raised to the power 3. And if you simplify it, is e raised to the power I 5 pi by 18 into raised to the power 3. And if you simplify it, becomes e raised to the power I 5 pi by 6. And if you simplify this, it becomes our option B, that is minus root 3 by 2 plus I by 2. If you want, I can simplify it. So if I simplify this part, e raised to the power I pi by 6, you can see that it becomes cos 5 pi by 6 plus I sin 5 pi by 6. Put the value and get the answer. Now again in 2023, similar type of question has been asked. Again, you can write the numerator into exponential form as root 2 e raised to the power I times 3 pi by 4. The denominator can be written as e raised to the power I pi by 3. And if you simplify it, is root 2 e raised to the power I 3 pi by 4 minus pi by 3. That is nothing but root 2 e raised to the power I 5 pi by 12. And if you see, directly B option matches. So this question can be done in under 30 seconds. Now an extremely simple question was in 2019. And this question you can do just by observing the question. No need to even lift your pen. If you look into this question, they are adding a complex number with its conjugate. So what we are adding is z plus z bar. If you add z plus z bar, the answer is going to be 2 real part of z. So I'm assuming this to be, let us say, z1, in order to avoid any kind of confusion. So what you can see is, what you should get is a real value, because you're adding a number with its conjugate. So by default, the imaginary part of z that is given in the question needs to be 0. Hence option B becomes correct. Now this question that was asked in 2013 is based on the similar logic of 1 plus cos theta that we saw earlier. So what we are saying is it has a unit modulus and argument is theta. So if I want to write this in polar form, it is nothing but cos theta plus I sin theta. So this is what we know about the complex number z. If I put it here in this 1 plus z by 1 plus z bar, it is going to become 1 plus cos theta plus I sin theta and 1 plus cos theta minus I sin theta. And if you simplify, what you get is 2 cos square theta by 2 plus I times 2 sin theta by 2 cos theta by 2 divided by 2 cos square theta by 2 minus 2 I sin theta by 2 cos theta by 2. So if you simplify this, 2 and cos theta by 2 will get cancelled out. And if you simplify this part, it becomes extremely simple. In the numerator, it is cos theta by 2 plus I times sin theta by 2. And in denominator, you have the same expression, but with a negative sign. So numerator part can be written as e raised to the power I theta by 2. Denominator will become e raised to the power minus I theta by 2. So answer becomes e raised to the power I theta. So your argument here is nothing but theta, and that is option C. And this logic of 1 plus cos theta, 1 minus cos theta, and sin theta using those half angle formulas in trigonometry is very important, will be used multiple times. Again, the 2023 questions based on similar concept. So what we can do is this 1 minus root 3 I. If I write in terms of exponential form, it is 2 times e raised to the power I minus pi by 3. So if I raise it to the power of 200, it becomes a 2 raised to the power 200 and e raised to the power I minus of 200 pi by 3. And this is equal to nothing but 2 raised to the power 199 p plus iq. Now your job is very simple. Simplify it, find the value of pq, and then do whatever they're asking you to do in the question. So if you simplify it, this becomes 2 into e raised to the power minus I times. Now if this you simplify, it becomes 66 pi plus 2 pi by 3. And I have already told you that e raised to the power 2 pi will have no significance on your question. So this becomes e raised to the power minus I into 66 pi into e raised to the power minus I 2 pi by 3 is equal to p plus iq. Now this part will become 1 because e raised to the power 2n pi form is there. So if we take the circle, it will come to the same part 1. And if I simplify, what I get ultimately is cos of minus 2 pi by 3 plus I times sine of minus 2 pi by 3 equal to p plus iq. And if I further simplify, this becomes minus 1 by 2 minus I root 3 by 2 is equal to p plus iq. If I simplify it further, the value of p comes out to be minus 1 and the value of q comes out to be minus root 3. Now let us go back to the question. What they're saying is they need to make a quadratic equation with these two roots. So if I find these two roots, the first one is nothing but p plus q square. So if I add p, that is minus 1, plus q, that is minus root 3, and q square, that is 3, it becomes 2 minus root 3. And if I do it for the other one, it is p minus q plus q square. So if I put it minus 1 plus root 3 plus 3, that is 2 plus root 3. If you use both of these roots, then the equation formation will be x square minus sum of roots into x plus product of roots equal to 0. If I do sum, it becomes x square minus 4x, and if I do product, it becomes 1 equal to 0. Hence our option B comes out to be correct. Now this very beautiful question came in 2021 and is amalgamation of few ideas. Let us see those ideas. So first, in order to understand what this is written, let us put z is equal to x plus iy. And if I do so, what I get from this is nothing but first part, or w, will become nothing but x square plus y square minus 2 times x plus iy plus 2. And if I simplify this, it becomes x square plus y square minus 2x plus 2, this is the real part, and plus minus 2iy, this is nothing but the imaginary. Now this is the first part. They have also given one more condition that z also belongs to this set. So let us also simplify that part. So z plus I ka mod is equal to z minus 3i mod. So if I simplify this, it is x square plus y plus 1 whole square. The second one is x square plus y minus 3 whole square. And if you simplify this part, this becomes y square plus 2x plus 1. X square will get cancelled out. Y square minus 6x plus 9. So again, y square will also get cancelled out. What we are getting is 8y is equal to 8, or y is equal to 1. Now you can see that the value of y is 1 here. So if I simplify my w becomes x square plus 1 minus 2x plus 2 and minus 2i. Now again, if I simplify this part, it becomes x square plus 2x plus 3 plus 2y. Why this is interesting? Because what we are saying is the real part of w becomes minimum. So now again, let us look into this. So if we have x square plus 2x plus 3, what can be its minimum value? So let us make the perfect square. So x plus 1 whole square plus 2. So you can see that this will become minimum when x becomes minus 1. So minimum value becomes nothing but 2. So let us find w minimum. It is nothing but 2 plus 2i. Now this is very interesting. What they are saying is 2 plus 2i. And what they are saying is what should be, and if I simplify this into exponential form, it will become 2 root 2 e raised to the power I pi by 4. Why are we writing this? Because now we are saying that this is w minimum raised to the power n. That means 2 root 2 e raised to the power I pi by 4 raised to the power n. This should become nothing but real. This can, what minimum value n can take? So it is obvious, if this n becomes equal to 4, answer would be real. So answer becomes 4. The type 8 problem type is nothing but questions based on cube root of unity. Now let us first look into the basic theory of cube roots of unity. So if I take x cube nothing but equal to 1, then it can be factorized into x cube minus 1 equal to 0. That would imply x minus 1 into x square plus x plus 1 equal to 0. So if I put x plus 1, x minus 1 equal to 0, I get the first cube root of unity, that is 1. And if I put the other one, that is x square plus x plus 1 equal to 0, I get two roots out of it. X is equal to minus 1 plus minus root of 3i by 2. So if I take plus sign, I get omega. So my omega is equal to minus 1 plus root 3i by 2. And if you square it, you get the another one, that is minus 1 minus root 3i by 2. There are three cube roots of unity, I, omega and omega square, like we have written here. Omega is this, and if we write in Euler's form or exponential form, it is e raised to the power I2 pi by 3. Omega square is nothing but minus 1 by 2 minus I root 3 by 2. And if I write this in exponential form, it is I raised to the power 4 pi by 3 or minus 2 pi by 3, same thing. If I talk about properties of cube root, the first property is if I have 1 omega and omega square, the sum of them is equal to 0. So 1 plus omega square equal to 0. You can put and check. Also, if I multiply all of them, that is omega cube, it comes out to even. Again, you can put and check. So these are two basic properties that will be used like 90% of the times. But there is one more idea. If I raise this 1 raised to the power r, omega raised to the power r, and omega square also raised to the power r, the value of this expression will depend on the value of r. If r is not a multiple of 3, then in that scenario, the answer is equal to 0. But if it is a multiple of 3, then the answer of this expression becomes equal to 3. You can put the values and check. If I plot them on an Argand plane, this is how they look like. So this is my 1. Then I2 pi by 3 would be some, omega would be somewhere here and then here. If I join all of them, this is how they look like. You can see that this angle from here to here is nothing but 2 pi by 3. And this angle again from here to here is 2 pi by 3. And this angle again from here to here is nothing but 2 pi by 3. So interesting part is that all of them lie on a unit circle. So if I draw a circle circumscribing this triangle, it is nothing but a unit circle. The radius of this is equal to 1. And that is because if you take the modulus value of all of these complex number, it comes out to be 1. So the distance from origin is equal to 1. Hence they lie on a unit circle. Another interesting part is, since this angle is equally divided, this triangle that we are talking about, this is an equilateral triangle. And if you want to find the area, it is not very difficult. You can do that as well. It is half of base into height. Now, once you have done this, this is the geometrical part analysis of this. One more idea that comes handy while solving problem is, instead of 1, if I take cube roots of minus 1, so this will become x cube plus 1 equal to 0, or x plus 1 into x square minus x plus 1 equal to 0. So you can see that one value comes out to be minus 1. And another two values, if you find, come out to be minus omega and minus omega square. Now, this is a very important result, especially if you have been given this quadratic equation. They are talking about roots of this equation. You can consider this as minus omega and omega square. Now, once we have looked into these basic results, now let us see what kind of questions JEE has asked on this idea. Now, let us look into this first question that came in 2004. And in this question, what you can see that all we have to use is two property. One is 1 plus omega square is equal to 0. So if they are asking 1 plus omega square, the value of 1 plus omega square is nothing but minus omega. And if I look into this second part, 1 plus omega raised to the power 4 they have written. Omega raised to the power 4 can be written as 1 plus omega, because omega cube is equal to 1. So whatever power they are raising to the power of omega, we need to divide it by 3. Whatever remainder is there, we will raise it to the power of omega. Like 4, if you divide by 3, the remainder is 1, so it becomes omega raised to the power 1. Now from this same identity, the value of 1 plus omega will come out to be minus omega square. Now if you take these two values and put it in the question, the left side becomes minus of omega raised to the power n. Right hand side becomes minus of omega square raised to the power n. So what we are getting ultimately is omega raised to the power n is equal to omega raised to the power 2n, or omega raised to the power n is equal to 1. This can only happen when n is a multiple of 3 and the lowest value can be 3. Now let us see another problem that came in 2021. What they are saying is the sum of the 1/62nd power of the roots of this equation. So let us find first the roots of this equation. So we can regroup it as x cube minus 1 and minus 2x into x minus 1 equal to 0. So you can see that from here and here I can take x minus 1 common. What is remaining is x square plus x plus 1 minus 2x equal to 0. So x minus 1 into x square minus x plus 1 equal to 0. Now from here we'll get one of the roots as x equal to 1. From here we have already seen this when I taught you the basic theory. The answer is minus omega and minus omega square. This is very handy. So what they're asking in the question is very simple. Raise all of them to the power of 162 and add them up. So minus omega raised to the power 162 and plus minus omega square raised to the power 162. If you do this first one, it comes out to be 1. Now you can see that omega raised to the power, to look into this quantity, it is a multiple of 3. So what will happen is basically this will become 1. This will also become 1 and the answer becomes 3. Now this next question was asked in 2020. The question is very simple. If you identify one fact, and what is that one fact is this value of alpha that they are giving in this question is nothing but omega. If you identify this, your life becomes very easy because then you can directly put it here as 2 plus omega raised to the power 4 is equal to a plus b omega. And your life becomes very easy because now you can use the properties of omega. So if I simplify this, this is nothing but 1 plus omega raised to the power 4 is equal to a plus b omega. 1 plus omega can be written as minus omega square raised to the power 4 is equal to a plus b omega. Now I am taking one power. So what we can do is we can write this as 1 minus omega square whole square is equal to a plus b omega. And now if I simplify this, this is 1 plus omega raised to the power 4 minus 2 omega square raised to the power 2 is equal to a plus b omega. And omega raised to the power 4 is nothing but omega only. So this is 1 plus omega minus 2 omega square raised to the power 2 is equal to a plus b omega. 1 plus omega can again be written as minus omega square. So again, if you simplify this, what you get is nothing but minus 3 omega square raised to the power 2 will be equal to a plus b omega. This, if you simplify, is nothing but 9 omega raised to the power 4 is equal to a plus b omega. And omega raised to the power 4 will again become omega only. So now if you compare both the sides, what you are getting, the value of a you are getting is 0 and the value of b you are getting is 9. So if I want to find the value of a plus b, it will come out to be 9 only. Hence my option B becomes correct. You can see that 90% times we are using the two very basic ideas, that is 1 plus omega square is equal to 0 and omega cube is equal to 1. Sometimes we use this idea that x square minus x plus 1 equal to 0 will have two roots minus omega and omega square. Now again, this question asked in 2022 appears to be a difficult question, but actually is a very simple question. If you identify just one thing, that is this equation. So the roots of this equation are nothing but omega and omega square. So I can take any one value and find the value of this expression. So for finding this expression, let us first go inside this. So what we have been given is z raised to the power n plus minus 1 raised to the power n by 1 by z raised to the power n whole square. So let us put in place of z omega. So this becomes omega raised to the power n plus minus 1 raised to the power n by omega raised to the power n whole square. And if you simplify, omega raised to the power 2n plus 1 by omega raised to the power 2n and then plus 2 minus 1 raised to the power n. And if I simplify this omega square, see, this is again very simple idea but important idea. If you multiply this by omega numerator denominator, it becomes omega by omega cube, that is equal to omega by 1 or omega. This is a simple and very powerful idea. So whenever we find 1 by omega square, you can directly replace it by omega. This is again a very small shortcut but very useful. So this becomes omega raised to the power 2n plus omega raised to the power n is equal to 2 into minus 1 raised to the power n. So we have simplified this enough. Now what we are going to do next is we are going to find the value of this summation and then take mod of it. Because there are two things. Mod is also there. Do not forget this mod. Sometimes you'll forget the mod and then you'll wonder why the answer is not coming. If I apply the summation, you can see that it will become summation of omega raised to the power 2n from n equal to 1 to 15 Then second becomes summation of omega raised to the power n is equal to 1 to 15. And the last part is 2 into summation of n is equal to 1 to 15 minus 1 raised to the power. So if you simplify, write this, it is nothing but omega square plus omega raised to the power 4 up till omega raised to the power 30. The second part becomes omega plus omega square plus omega cube, and again up till omega raised to the power 15. And the last part, if you write, will become 2 times minus 1 plus 1 minus 1 plus 1 and up till minus 1. Now if you closely observe this series that we have, this series omega plus omega square, you can see that in this, the first term, if I look into this one, the first one, if you closely observe the 3 terms, omega square, omega raised to the power 4, omega raised to the power 6. So this is omega square only, but this will become omega and this will become 1. So it is 1 plus omega square becomes 0. So the pair of 3 terms will become 0. So ultimately the first part will become 0 only. Why? Because omega square, omega raised to the power 4, omega raised to the power 6 becomes 0. Then omega raised to the power 8, 10 and 12 will again become 0. So like this 3 pairs are becoming 0. Similar thing is happening with this part also. So this also becomes 0. So no calculation you need to do. And this part also, if you take pairs of 2, it is becoming 0. So till 14 it will be 0. But last one, minus 1 will remain. So answer becomes nothing but minus 2. So it is very simple to calculate it. Now this is not the answer, we need to take modulus. Hence 2 is our answer. Now this 2019 question is again very simple question. Why? Because if you observe this x square plus x plus 1, you will be able to identify the root as omega and omega square. In order to find the value of z, since it is a single option correct question, you do not need to consider both the values. Take any one. I am taking omega. So if you write this z, it is nothing but 3 plus 6i omega raised to the power 81 and 3i omega raised to the power 93. Now this is also a multiple of 3. This is also a multiple of 3. So both of them will become 1. So this becomes 3 plus 6i minus 3i, or it is nothing but 3 plus 3i. If you look into this, the argument of this comes out to be pi by 4. Hence A option becomes correct. Again, a very simple question that came in 2020. In this question, they have given the value of alpha, and again, your job is very simple to identify that this is omega that is given to you. Now let us look into the question. If A they are talking is nothing but 1 plus omega, I am replacing alpha by omega. Summation of k is equal to 0 to 100 omega raised to the power 2k. If I simplify this, this becomes 1 plus omega. And if I write this, it is 1 plus omega square, and it will go up till omega raised to the power 200. So it will become 1 plus omega. And if I apply the sum of geometric progression, it comes out to be a into r raised to the power n minus 1 by omega square minus 1. Because your value of r is nothing but omega square. This becomes 1 plus omega. Omega raised to the power 202 minus 1 by omega minus 1 and omega plus 1. Omega plus 1 gets cancelled out. If you simplify this, this is nothing but omega only. So omega minus 1 by omega minus 1 again gets cancelled out, comes out. So the value of A is nothing but 1. Now let us look into the value of B. If you look into the value of B, it is omega raised to the power 0, omega raised to the power 3. All the powers are multiple of 3. 300. You can see that all of them will become 1. And hence the answer becomes 101. Now one root is 1, another root is 101. So the product of root will become 101 only. And hence, if you look into this, option A will become correct.
Now this next 2024 question is kind of sort of based on Newton's theorem. If you look into this question, then the first step, what they're saying is, if you have this equation x square minus x plus 2 equal to 0, then alpha and beta are the roots such that imaginary part of alpha is greater than the imaginary part of beta. They have also given us this relation. We need to solve it. So now, if alpha is the root, then alpha square minus alpha plus 2 will be equal to 0. So if I have alpha square plus 2, this will be equal to alpha. And if I have this, I can square both the sides. So it is alpha raised to the power 4 plus 4 plus 2 alpha square. This will be equal to alpha square, 4 alpha square. You can see that what we are getting is alpha raised to the power 4 plus 3 alpha square plus 4 is equal to 0. You can see that when we want to evaluate this, alpha raised to the power 4 can be figured out from here. Second thing that we have is alpha raised to the power 6 also. So for that, let us multiply with alpha square. So if we do so, it is alpha raised to the power 6, 3 alpha raised to the power 4, 4 alpha square equal to 0. If I want to find the value of alpha raised to the power 6, it will be nothing but minus 3 alpha raised to the power 4 minus 4 alpha square. Now alpha raised to the power 4 we can resubstitute from here. It is nothing but minus 3 alpha square plus 4 minus 4 alpha square. So if I simplify it, what am I getting is nothing but 9 alpha square from here, and then minus 12 minus 4 alpha square. So what we are essentially getting is 5 alpha square minus 12. Now see, from this first relation that we have, alpha square can also be written as alpha minus 2. So we can also replace this and write this as 5 times alpha minus 2 minus 12. And if I simplify, it is 5 alpha minus 10 minus 12. So that becomes 5 alpha minus 22. So this is what is the value of alpha raised to the power 6. Now alpha raised to the power 4, if I want to write, it can in turn be written as nothing but minus 3 alpha square minus 4. And here if you substitute the value of alpha square like we did here, it is alpha minus 2 minus 4. So this value becomes nothing but minus 3 alpha plus 6 minus 4. So becomes minus 3 alpha plus 2. And now we have figured out the value of alpha raised to the power 6, alpha raised to the power 4. Similarly, if we have done the same process for beta raised to the power 4, the answer would not be different. It will follow the similar mechanics, will become 3 beta plus 2. Now we can see that we have figured out everything. We can substitute the value here and use the sum and product of roots to get the answer. So this 2024 question says that z is a complex number such that the common roots of this equation is equal to. So now you can see that if they have given us this equation, this in turn can be written as nothing but, what I can do is I can take z cube plus 1 on one side and then 2z on the other side. So z plus 1 will come. This can be written as z plus 1 into z square minus z plus 1 plus 2z times z plus 1 is equal to 0. So you can see that z plus 1 can be taken common. What you have is z square minus z plus 1 plus 2 times z is equal to 0. And if you look into this expression, something very unique comes out. So z square plus z plus 1 is equal to 0. See, now one root will get from here, that is minus 1, and two roots from this expression will become omega and omega square, as I told you earlier. Now these results are important. Using this, now we will check the common roots. So I will take minus 1, substitute and check whether it satisfies or not. So let us take z as minus 1, put it here. So first term will become minus 1, second will become 1, then 1. So you can see that this is not equal to 0. Second, let us take it as nothing but omega. And if I take omega, it is omega raised to the power of 1985 plus omega raised to the power 100 plus 1. Now if you look into this, if you add to it, we are checking divisibility from 3. So that is nothing but the sum of the digits should be divisible by 3. So 9 plus 1 will become 10, 10 plus 8 will become 18, and 18 plus 5. So you can see that this will become omega square. And this will become omega and this becomes 1. So 1 plus omega square becomes 0. So you can see that this is the root. Sorry. Similarly, I can put z is equal to omega square. And if I take this value and again substitute omega square raised to the power 1985 plus omega square raised to the power 100 plus 1 will come. And if I simplify this, this will become, first term will become omega, second will become omega square, third will become 1. And if I see, again it comes out to be 0. You can see that there are two roots, omega and omega square. Now what they are asking is the number of common roots of this equation. The number of common roots are nothing but 2. If I look into this next question, this 2024 question says that alpha satisfies the equation that is given to us, then 1 plus alpha raised to the power 7 is equal to a plus b alpha plus c alpha square. Then find the value of this expression. So you can see that if I want to solve this question, the first step should be to observe that this is nothing but my non-complex roots of unity. So roots will be nothing but omega and omega square. So I can take the value of alpha as either one of them. So in the second step, let us take alpha as nothing but omega. Substitute here and see. So what we have got is 1 plus omega raised to the power 7. This is equal to a plus b omega plus c omega square. So if I do so, this can be written as minus omega square raised to the power 7, because 1 plus omega square is equal to 0. So this will become a plus b omega plus c omega square. You can see that this is minus omega raised to the power 14, a plus b omega plus c omega square. Omega raised to the power 14 till 12 it will become 1. So this is nothing but omega square. This is a plus b omega plus c omega square. If you compare the coefficients, before doing that, let us take everything on the same side. So a plus b omega plus c plus 1 omega square is equal to 0. See, this can only become 0 if what we have written here, a, that becomes nothing but 1. In the next step, a becomes nothing but 1, b becomes also 1, and c plus 1 also becomes 1. So you can see that c becomes equal to 0. Let us substitute this value. So 5 times 3 times a, 2 times b minus c. If I simplify this, this is 5, 3 minus 2. Answer comes out to be 5. Let us start with next problem type, that is based on the concept of rotation. Let us first understand what the concept is and then see what kind of question JEE has asked on. The concept is very simple. If I draw very simple, take two very simple points on the Argand plane. The first point is nothing but z2 and the next point is nothing but z3. These points are in such a manner that this angle is z theta 2 and this angle is nothing but theta. If I want to write z2 in exponential form, it will be mod of z2 e raised to the power I theta 2. Similarly, it will be nothing but z3 mod e raised to the power I theta plus theta 3. Why so? Because this angle from here to here would be nothing but theta plus theta 2. Once I have written that, I can divide both of them. So z3 by z2 would be equal to z3 mod by z2 mod e raised to the power I theta plus theta 2 by e raised to the power I theta 2. So if I simplify this, I get a very simple expression. Z3 by z2 is nothing but z3 mod by z2 mod e raised to the power I theta. Now what we are doing is, this we have done when the third point, the point about which we are rotating it, is nothing but is at origin. Now I shift all of the system onto a point z1, then this is how it looks like. And this is nothing but z1, this is nothing but z2, and this is nothing but z3. So the same thing I can write again. This is nothing but theta 2, this is nothing but theta. But instead of z2, now I will write z2 minus z1. And here also I can write z2 minus z1 mod e raised to the power I theta 2. For the another one, I can do the same thing. Z3 minus z1 is equal to z3 minus z1 modulus e raised to the power I theta plus theta 2. And again, if you divide them, it becomes z3 minus z1 is equal to z3 minus z1 mod e raised to the power I theta plus theta 2 and z2 minus z1 into z2 minus z1 mod e raised to the power I theta 2. So if I divide it, it comes out to be z3 minus z1 by z2 minus z1 is equal to z3 minus z1 mod by z2 minus z1 mod e raised to the power I theta. And this is known as the rotation formula. Now let us look into this first question based on rotation that came in 2022. If you look into this question and if I draw a small diagram, the question says that there is a complex number z1 and the value is 1 plus 2i. And this is your complex number z1. Now what we are saying is there is another complex number z2 in second quadrant, because they have given real part of z2 is smaller than 0 here. And if I join
This is O, this is A, this is B, and this angle is given as 90. This is hypotenuse and this is the isosceles triangle. So OA is equal to AB. That would mean this angle BOA will be nothing but pi by 4. And also we know the value of OA. OA is nothing but mod of 1 plus 2i, that comes out to be root 5. You can observe here, if OA is root 5, AB will also become root 5. And since OB is nothing but hypotenuse, it will become root 10. Pythagoras theorem. A square root of A square plus B square is equal to C square. Once you do this, now we can find Z2 using rotation formula. So Z2 by Z1 is nothing but Z2 mod by Z1 mod e raised to the power I times pi by 4. If I simplify this, my Z1 is 1 plus 2i, and this is root 10 by root 5, and this is 1 by root 2 plus I into 1 by root 2. And if you simplify this, Z2 becomes nothing but 1 plus 2i into 1 plus I. And if you simplify this, it becomes nothing but 1 plus 3i minus 2, or minus 1 plus 3i, and it is in link with what is given in the question that it needs to be in the second quadrant. So it is there in the second quadrant. So by doing this, you have found the value of Z2. Now all we need to do is basically check the options. So if you find the argument of Z2, option A comes out to be correct. This is fine. If you find mod of Z2, option D is also correct. Now what they are asking is which of the following is not true. So this is true, this is true. Now let us check B and D options. So if I check my B option, for that what will I have to do is I will have to find Z1 minus 2Z2. It comes out to be nothing but 1 plus 2i minus 2 times minus 1 plus 3i. And if I simplify, it becomes nothing but 3 minus 4i. So if you find the argument, this B option also comes out to be correct. So by elimination, you can say D option is wrong, or in our case, the correct answer. And or you can still find the value of 2z1 minus z2. So 2 times 1 plus 2i minus of minus 1 plus 3i. If you simplify this, this is 2 plus 4i. And this becomes plus 1 minus 3i. And if you simplify this, nothing but 3 plus I. And of course, it is not equal to root 5. Hence, this D option is wrong, and hence our correct answer. Now, next, let us look into a very interesting question that came in 2023. In this question, what they are saying is there is a complex number Z1. And this Z1 lies in first quadrant. It is nothing but 5 plus 4i. What we are doing is we are rotating this by 90 degree in anti-clockwise direction. And if I do so, I get my W1. Now, there is another complex number the question talks about. Now, this is also in the first quadrant. So, if I try and draw it, it is 3 plus 5i. So, this is 3 plus 5i. And I am rotating it in clockwise direction like this. So, now the value of this is nothing but W2. What they're asking is what will happen to W1 minus W2, and the argument of that part. So let us first find W1. So if I want to find W1 by Z1 is nothing but W1 mod by Z1 mod into e raised to the power I times pi by 2. Now you can see that since the moduluses are equal, it becomes e raised to the power I pi by 2, and this is equal to I only. So the value of W1 is nothing but 5 plus 4i into I, which comes out to be minus 4 plus 5i. Now we can do the same kind of calculation for the W2 part. Here also, if I apply rotation, it is nothing but W2 by Z2 is nothing but W2 modulus by Z2 mod e raised to the power minus I pi by 2, because now the direction is reversed. Now we are going in clockwise direction, so angle will become minus pi by 2. If I put these values, again mod of Z2 and W2 are equal, and Z2 was equal to 3 plus 5i. E raised to the power minus I by 2 will become minus I. If you simplify this, the value of W2 comes out to be 5 minus 3i. And now if I find W1 minus W2, it is nothing but minus 4 plus 5i and minus 5 plus 3i. So it becomes nothing but minus 9 plus 8i. You can see that this is in second quadrant, and if I find the principal argument, it will become minus pi minus 10 inverse 8 by 9. So my option C becomes correct. Now let us look into a very interesting question that came in 2008. In this question, all we need to do is trace the path of a particle. So if I make a coordinate plane, and you can see that I can solve this question
by converting this question into a question of coordinate geometry. So what they're saying is, instead of point Z0, where it started from, let us take the initial point as nothing but 1, 2. Now this is my Z0 point. What we are saying is the moves first horizontally away from the origin by 5 units. So it is moving like this, 5 units. If I do that, this point will become nothing but 6, 2. Then it moves vertically away from the origin by 3 units and reach point Z1. So it has reached here Z1. And by this time it is 6, 5. Next, what the question says is, this starts moving in the direction of I cap plus j cap. You can see that since the x and y coordinate are equal, what we can say that this moves at an angle of 45 degree here onwards. Now it is moving √2 in this direction. That would mean the effective movement in x and y direction is 1, 1. So now this point as a result will become 7, 6. So this is where we have reached. Now what they're saying is, once you have reached this point, you need to rotate it by in anti-clockwise direction by pi by 2. So now let us go back to complex numbers. So from complex numbers point of view, we are at 7 plus 6i. If I want to rotate it in anti-clockwise direction, so I can write this as mod of z by 7 plus 6i ka mod into e raised to the power I times pi by 2. To do this, you know that this part, both the magnitudes are same. So z becomes 7 plus 6i into I, that becomes minus 6 plus 7i. And that matches our option D. So you can, in this manner, very imaginatively convert a question into a question of coordinate geometry, solve and again convert it back into a question of complex number. Now let us move on to the next problem type, that is line. Before we start line, we should understand a very simple concept of complex number as vectors. What does this idea means is, let us say we have a complex number z and we have a complex number z1. So if I join this line z minus z1, it acts like a vector in Argentine. Now this idea is very important because we are going to use this idea to write different forms or equations of a straight line. Let us start with that. So if we have a straight line, let us say the first way of expressing it would be using argument. If I say argument of z is equal to pi by 6, what does this mean? This means all those complex numbers. Now you can see that since we are writing z, there is inherently z minus 0%. If I am taking this z, this means I am connecting this point to the origin. And then this vector should be at an angle of pi by 6. So you can see that this will represent a ray starting from origin going till infinity at an angle of pi by 6. So like in straight lines, we have a concept of line and line segment. In this complex number, we also have a concept of ray, and JEE has used this beautifully in JEE Mains and advanced questions. If I move towards next idea, it is if I try to move this point from origin to some other point. So if I write like z minus a, argument of this equal to pi by 6, what will this mean? So if I again write this, this would mean now your ray starts from a point A, and this z, this will become our vector. Now this is at an angle of pi by 6. You can see that the starting point is now shifted from origin to point A. Now if I take this idea further, what I can do is I can also represent different parts of a straight line. And what does that mean? Let us say that we have this z1 here and z2 here. So you can see that there is this one part of the straight line, that is the z1, one after z2, and let us say another part of this line lies between z1 and z2. So you can see here that there is this first part that is before z. So if I take a point here, if I take a point here, so z minus z1 is this vector, and if I write z minus z2 vector, that will also be in the same direction. So what we can see is the angular difference between z minus z1 and z minus z2 is equal to 0. Also, if we have considered this point on this side, the same kind of relationship will still hold, because again the angle between z minus z1 and z minus z2 will be equal to 0. So this also represents equation of straight line, but it does not represent the middle part. It expresses the part that is beyond z1 here and z2 there. If I want to write this blue part, how to express this? So if I take any 2 points here, let us say that now I am considering a point z here. So in this new scenario, if you write argument of z minus z1, and if you subtract argument of z minus z2, you can see that now the difference between that will be equal to pi. So this middle part will come when the difference between both the vectors is equal to pi. So it is a very beautiful and simple concept. Another way of expressing this comes using this determinant form like we used to do in area. So this is a lot of similarity with that area concept. If you see, we have written z bar 1, z1 bar 1 and z2 bar 1 equal to 0. And if you open it up, what you will get is you will get a general form of a straight line that looks something like this: a bar z plus az bar plus b equal to 0. About this form, there is one more interesting idea, that if I express this in this form, z is equal to minus a by a bar z plus b, you can see that this looks like nothing but a kind of a slope, and this part is also known as complex slope. We can also write this as ai by ai bar. The next type of form of straight line and directly comes from the concept of vectors. So if I am writing this z minus z1 into k times, where k is a real number, z1 minus z2, so it is like writing two parallel complex number, parallel vectors, like b vector is equal to lambda vector. So we are trying to borrow this idea from vectors directly. When we start treating it like vectors, it will start acting this manner. And if I simplify, I get this parametric form. Now, if I simplify any of these forms, it can be expressed into this general form, that is a bar z plus az bar plus b equal to 0. I'm not going to derive it here. That derivation you can study. Important thing is, a vector that is parallel to this line can be written as ai. So directly from here, we can get a vector that is parallel to this line. Now, what if I do z minus z1 mod is equal to z minus z2 mod. So now, if you simplify this, what you are going to get is those complex numbers which are at an equidistance from z1 and z2. So this becomes the equation of perpendicular bisector. So, and this has been used multiple times when we write z minus I mod is equal to z minus 2i mod. What would this mean is a line. So if I mark I and 2i, so this is my 2i and this is I. So a line which is equidistant from these two lines, so it will become a perpendicular bisector like this. So without doing anything, we can write this equation as y is equal to 3 by 2, or all those points that has imaginary number equal to 3 by 2. Now, if we move towards the problem, the first most simple problem was asked in 2019. Directly equation of angle a perpendicular bisector is given to us. Z minus Z1 mod is equal to Z minus Z2 mod. And they're asking what is the locus. So directly you can say a line. Now a line. So line is coming. And there are two kinds of line they are talking about. Now if you mark these points, you'll be able to understand what kind of line. So if I mark my first point, that is I. And another point, that is 1. So we are talking, if I join these 2 points, we are talking of an angle bisector. So this line is going to be something like this. So the slope is going to be +1. Hence B option becomes correct. Now, instead of doing this, you could also have put z is equal to x plus iy. So it would have become z plus iy minus 1 mod is equal to x plus iy minus 1 mod. So this becomes nothing but x square plus y minus 1 whole square root is equal to root of x minus 1 whole square plus y square. So if you simplify this, it is x square plus y minus 1 whole square is equal to x minus 1 whole square y square. And if you simplify, what you will get is nothing but x square plus y square minus 2y plus 1, x square minus 2x plus 1 plus y square. So your x square y square will get cancelled out. Your 1 will also get cancelled out. And what you are getting is y equal to x. That is nothing but a straight line with slope 1. So this is another method of solving the same question but without geometry. Now next problem type is based on the concept of circle. So if I look into the basic equations of circle, the first and the foremost equation is very simple. If we have something like z minus z1 or z0 mod is equal to r. Now you can see that what we are saying is all those points which are at equidistant from a point z0 and the distance is equal to r. So z0 will become the center of the circle and r will become the radius of the circle. So if I represent it in a form of a diagram, this is how it looks like. Now we can see that if I take this mod and put here greater than r, then we are talking about those points which are at a distance from z0 which is greater than r. So this will represent points outside the circle. So if I try and sketch them on the diagram, we are talking about these points which are outside the circle. Now if I move further and if I write this z minus z0 mod is smaller than r, then what we mean is those points which are lesser than r distance from z0. That would mean that the points which are inside the circle. So if I try and shade it out, this is how the points are going to look like. Fine. So equal to r would mean on the circle, greater than r means outside the circle, and smaller than r would mean inside the circle. Now the next kind of equation of a circle can be represented by writing it as z minus z1 by z minus z2 mod is equal to k. See here k, this need not be equal to 1. So what we are saying is k is greater than 0, and obviously because it is value of modulus, and it is not equal to 1, because in case of 1, when k is equal to 1, it will become perpendicular bisector. This we have already done, and a 2019 question came on the same idea. What we are here saying is if k is greater than 0, if k is greater than 0, and if I simplify this becomes a circle. You can easily prove this by putting z is equal to x plus I1. The next idea is based on Pythagoras theorem, that if we have a point z like this, that this is nothing but z minus z1 mod, this side will become z minus z2 mod, and this side is nothing but z2 minus z1 mod, and this is following nothing but Pythagoras theorem, like z minus z1 mod whole square plus z minus z2 mod whole square is equal to z2 minus z1 mod whole square. So you can see that now it has become a part of Pythagoras theorem. So if it satisfies Pythagoras theorem, this would mean this angle that we are talking about is nothing but 90 degrees. So this will always happen when this point lies in a semicircle. So what we are seeing is this form represents a circle, and not any circle, a kind of a circle for which the extremities of diameter are given to us. So all the points on the circumference of this circle are going to satisfy the equation or the condition that is given to us. Now we can express the locus of major and minor arc using complex numbers. Now let us understand how. So let us say if I take argument of z minus 1 by z minus 2 is equal to pi by 6. Now let us see that, let us understand what this is going to express. Okay, so let us mark these points on the eigenplane. So this is 1, this is 2. So what we are saying is, if I take a point z here on this side, then this vector that connects z to z1 is nothing but z minus z1 vector. And if I connect this point to z2, this vector is nothing but z minus z2 vector. So what we are saying is, if I start from z1, z minus z1 and go towards z minus 1, the angle would be plus pi by 6. So if I do that here, this will be wrong, because if I'm going from z minus 1 to 2, the angle is clockwise direction, so this angle is negative. So this cannot be on this side. But if I take it on the other side, here, now this is z, so this becomes z minus 1, this becomes z minus 2. So now if I'm doing this, now we can see that if I go from z minus 2 to z minus 1, it will be in positive direction, so this angle can be pi by 6. Also, if I draw this locus, all that point that are going to do this will come out to be a circle, because there is a property that if I take any point on the circle, this angle always remains same. We are using this property that this angle will not change. And if this angle is actually smaller than pi by 2, or between 0 and pi by 2, then this arc is going to be a major arc. So when we are saying this pi by 6, this would mean it is a major arc. And the direction will change. Now here, instead of this, if I write nothing but argument of z minus 1 by z minus 2 is equal to minus pi by 6, the orientation will change. Now we are talking about this major arc. And the below part is not coming, the dashed part is not there, only the solid part is there. Because now the angle is in the opposite direction, anti-clockwise and clockwise, that you need to take care of. This is very important, because JEE Advanced has made question on similar kind of idea. Now that question can be asked in JEE Mains. Now if I change this concept a little bit, and if I write argument of z minus 1 by z minus 2 is equal to 2 pi by 3. Now you can see that the angle is no more between 0 and pi by 2. It is between pi by 2 and pi. So what will happen is, in this case, we are going to get major arc. So what is happening here is the point remains same, but you can see now this arc is minor arc. So between 0 and pi by 2 major arc, between pi by 2 and pi minor arc. So everything else is same. Now angle you can also see here, we are going from here to here, so it is positive only. And if I change this question a little bit and write here argument of z minus 1 by z minus 2 is equal to minus 2 pi by 3. Sorry, yeah, correct. So if I do this, again this will 1 and 2, but it will come on the other side, because now you can see that from z minus 1 to z minus 2, I am moving in a negative direction. So still it is a minor arc, but the orientation changes. Now if I want to express a semicircle, then you can see that instead of writing a number between 0 and pi by 2 and pi by 2 and pi, I am going to write pi by 2 only. Now interestingly, what is happening here is, again, if I write it here in the form of an example, z minus 1 by z minus 2 is equal to pi by 2. Now you can see that if I draw here, this is 1, this is 2. So the angle between them needs to be pi by 2. So what we are talking about is, we are not talking about this top part of semicircle. We are talking about the bottom semicircle. So in this case, we are getting only half of the circle, and that to bottom half. If I want to get the upper half, what I will do? I will write argument of z minus 1 by z minus 2 is equal to minus 5 by 2. In this case, I will get the top half of the same circle. So it is an equation of semicircle. Now, if you look into the next idea, it is nothing but the general equation of a circle. So what you can do is you can take the same equation that we wrote earlier, z minus z1 z minus z naught mod is equal to r. And if I square it on both the sides, I can simplify this. This will become z minus z1 z naught z naught bar is equal to r square. And if you simplify this, it comes out to be an equation of this form. So if you simplify this, it will become z bar plus a bar z plus a z bar plus b equal to 0. So this becomes nothing but the general equation of a circle. And here, if you compare, and once you get both the equations and compare, you will get the center of this circle. So if I draw this circle, the center of this circle will be nothing minus a. And the radius of this circle would be nothing but root of mod of a whole square minus b. Now this is not very difficult. No, not such a difficult question is going to come at mains. So you just have this idea that whenever you look into this kind of an equation where z in the equation of a straight line. So if you remember that this part was nothing but the equation of straight line. In that, if I add this one more part, and this is very important, if I add this one more part, it becomes the equation of circle. If you remember this much, when this kind of equations come in the question, you will be directly able to identify that, oh, it is a circle, and then you can solve it. Now this first question is again very simple, that came in 2020. If you look into this question, see, if I look into this first part, you can see that it is nothing but z minus I mod is equal to z plus 2i mod. And once you look into this, you should remember the idea of perpendicular bisector. What we understand is if I plot it down and represent the top point as I, the bottom point as minus 2i, it is talking about a perpendicular bisector of this line joining these 2 points. So that is going to pass through here at a point nothing but minus 1 by 2i. So this is quite simple to solve if you remember the concept. If you do not know the concept, then put z is equal to x plus iy and then solve. That also will give result, will take more time. Now if you recognize the second idea, it is nothing but equation of circle. Mod of z minus z naught equal to r. So you can see that your z naught is nothing but 0 and your r is nothing but 5 by 2. So they are talking about a circle that is like this. Radius of this circle is nothing but equal to 5 by 2. Now, if I solve them simultaneously, I'm talking about a point on this circle with coordinate x and y coordinate as minus 1 by 2. So if I write the equation of the circle, it is nothing but x square plus y square is equal to 5 by 2 whole square. The value of y I know. This is nothing but y square will become 1 by 4. This is 25 by 4. The value of x square comes out to be 24 by 4 or 6. Once you have got this, in the third part or in the third logic, what they're asking is value of this part. Now z you know. What is z? It is nothing but plus minus root 6 minus 1 by 2. So put it here and find the answer. So if I put and find the answer, it becomes root 6 plus minus 1 by 2 into I plus 3i mod. And if I simplify this, this comes out to be 7. Quite a simple question. If you just identify. So see, my point of telling you equations was not that you should remember all the forms. Definitely it is better to remember all the forms. But even if you can identify by looking into question what kind of geometrical figure we are talking about, we have won the battle. If I move on to the next question, it is nothing but a question of coordinate geometry asked in the garb of complex numbers. So our idea is very simple. Convert this question into a question of coordinate geometry and then solve it. This is going to be our main method of solving questions involving geometry of complex numbers. Now, why us knowing those complex equations of circle are important or lines are important? Because we can understand the coordinate form faster. Like in this case, what they're saying is if I look into whatever is inside the mod, z minus 3 minus 2i, then they're putting mod and is smaller than 4. This would mean a part of a circle whose center is at 3, 2 and radius is 4. Whatever is inside the region, that will happen. And if I put greater than 1, this part would mean the region outside a circle of radius 1. So if I draw both of these on the same circle, it is going to be region between two circles. So what we have is this bigger circle and then we have this smaller circle. These are concentric because their center is given as same as nothing but 3 minus 2, and this radius is 1 and this bigger radius is nothing but 4. And now what we are talking is the region that is between these two circles. So we are talking about this region. Okay, so this is important for us to interpret in this manner. Now see, you can see that after this I have made it a question of coordinate geometry. Why? Because now what they're asking was number of elements in Z for which both the coordinates, x and y coordinates, that is a and b in this case, would be integral in nature. For solving this question, what I will do as a student is, I understand that whether I write it from 3, minus 2 or 0, 0, it will not change. So what I will do from coordinate geometry is I will shift to the origin. So instead of writing this, let us write the center as 0, 0. It is not going to make any difference in the answer. Why? Because 0, 0 is also an integer and 3, minus 2 is also an integer. So whatever the number of points, they are not going to make any difference. Now once we have done this, it has simplified our job to a large extent. Now, how to count number of integral points? There is a method for that. What is the method? If I draw a line, we can start from drawing line at the center. Now this point we know is going to be nothing but 1, 0, and this point is nothing but 4, 0. So what I'm going to do is, now let us simplify this equation into this equation. We want this to be between 16 and 1. I've shifted my origin to 0, 0, so this has gone away. And because of that, I was able to write this equation. Now, because after this simplification, this question becomes extremely easy. Now, what you can do is, for finding points at this where the x coordinate, y coordinate is equal to 0, just put y is equal to 0 here. If I put y is equal to 0, what happens is my x square lies between 1 and 16. So you can see that your x can take a value like minus 3, minus 2, 3 and 2. So I'm not considering value that is equal to 1. So between 1 and minus 1, that value cannot be considered. So what we are getting corresponding to these 4 values is 4 points. So from here we have got 4 points. Now similarly, if I put y is equal to 1 here, what I'm going to get is x square plus 1 lies between 16 and 1. So my x square lies between 0 and 15. So the possible value when this can happen for x is nothing but, we need to take 1, minus 1, then 2, minus 2, and 3 and minus 3. So you can see that in this case we have nothing but 6 values. Now you can see if I'm drawing a line at 1 here, not like this, let's draw more up to the scale, like this. There is one line below also possible. So corresponding to this there are 6, and if I would put my y is equal to minus 1, I will get another 6 points, and that is nothing but this below line. And now I need to go till 4. So if I put again y is equal to 2, correspondingly this becomes 1 is x square plus 4 is smaller than 16. So from here what you're getting is x square is smaller than 12. So the possible values of x are nothing but 0, 1, 2 and 3. So again what we are getting is 4 points. And now what you can observe here is, we have got this 4 points, but not just 4 points. Corresponding to this, a value of x can be negative also. So minus 2, minus 1 and minus 3 is also possible. So these 3 more points will make it total 7 points. Now this can also happen for y is equal to minus 2. Considering that, we also need to multiply by 2. And in the last part, what we can do is we can put here y is equal to minus 3 or plus 3. So plus 3 and minus 3 both we are going to put. Now let us put either of these values. So x square plus 9 is smaller than 16 and 1. So only this side would give us a valid result, will be smaller than 7. So possible values of x are nothing but 0, 1, 2. Because at 3 it will become 9, and correspondingly minus 2 and minus 1. You can see that again 5 values. Since we are also considering for y is equal to minus 3, and we will have to multiply by 2 here. So now let us sum it up. So what we have got for the first case was 4. For next case, it was nothing but 6 into 2. For the next case, 7 into 2. For the last case, it is again nothing but 5 into 2. If you sum it up, it comes out to be 40. That is nothing but answer of our question. Now again, this is a very simple question that was asked in 2023. Now if you remember this equation, I told you in the starting that if we have something like z minus z1 mod by z minus z2 mod is equal to k, it is bound to be a circle if k is greater than 0 and k is not equal to 1. Here the value of k is given as 2. So after you remember this result, you can instantly understand that this locus is going to represent a circle only. And they have given it also that the center and the radius of the circle are nothing but alpha, comma, beta and gamma. Find the value of this expression. So all we need to do is find the equation of the circle, get the center and radius and put it in this variable or the expression that they're asking us to do and find the value of it. What we can do here is put the value of z as x plus iy and take mod. If I do that, this is what I'm getting, x plus iy minus 3 mod. And if I do it, it is x minus 2 whole square plus y square, and this is nothing but root of x minus 3 whole square plus y square. And if I simplify, what I get is x square minus 4x plus 4 plus y square. And this becomes 4 times x square minus 6x plus 9 plus y square. And if I simplify this, you can see that we will ultimately get 3x square plus 3y square minus 20x, and then 36 minus 4 will be 32 equal to 3. And if you divide it by 3, what you get is nothing but a general equation of a circle which looks like this. Once you have done this, now if you find the center of the circle alpha comma beta, it is nothing but minus g comma minus f. That comes out to be nothing but 10 by 3 comma 0. And if I want to find the value of r, or the radius or the gamma in this case, it is nothing but root of g square plus f square minus c. So that comes out to be nothing but 10 by 3 whole square minus 32 by 3. Once you do this and figure out the value of gamma, it will come out to 2 by 3. And now we have got the value of alpha as nothing but 10 by 3. We have got the value of beta, that is nothing but 0. We have got the value of gamma, that is 2 by 3. If I put it in alpha plus beta plus gamma into 3, the answer comes out to be 2. So it is quite a simple question. If you just put z is equal to x plus iy, you will get the answer. Now this next question that was asked in 2023 is a very interesting question because it is based on diametrical form. So when we were doing the basic equation, we came across this equation wherein we were using Pythagoras theorem. So what we did was basically we took this z1 and z2 as extremities of diameter and we connected it with one of the points on the circumference. And then we said that if I take this point as z, then the equation of this can be written as mod of z minus z1 whole square, z minus z2 whole square. And this will be equal to z2 minus z1 mod whole square because this angle is 90 degree and Pythagoras theorem will get satisfied. And here we also told that this z1 and z2 are nothing but extremities of diameter. Now instead of giving this, what they have done is they have replaced this z1 and z2 by alpha and beta. So instead of writing z1, z2, they have written here alpha and beta. So this becomes alpha, beta, alpha, beta. Then ideally this should become alpha minus beta whole square. But instead of writing this, which is nothing but 2 times radius, that is nothing but diameter, instead of writing this, they have given this value as 2 times lambda. So what we can write from here, 2 times lambda is nothing but 2 times r whole square. Because alpha minus beta mod is nothing but twice of radius or diameter. Once you got that, what they have also given is the value of lambda radius, that is lambda minus 1. So if I put it here, it is 4 times lambda minus 1 because here r is nothing but equal to root of lambda minus. If you put these values here, you can see that you can cancel out 2. Your lambda will be equal to 2 lambda minus 2, or lambda becomes equal to 2. If lambda is equal to 2, what they are asking is value of alpha minus beta ka mod. And we know that the square of this was equal to 2 times lambda. So alpha minus beta ka mod ka whole square is 2 into 2. So the value of alpha minus beta modulus comes out to be 2. Now let us look into this next question of 2023. The question is quite simple. It talks about a circle whose center is given as nothing but 1 by 2 comma 3 by 2. So you can see that I am converting this question into a question of coordinate geometry in real time. And that is the technique of solving such kind of geometrical questions. So this is given. And now what they're saying is the radius of this circle is equal to 1. That is fine. Apart from that, they have given that there is a point z1 equal to 1 plus I. If you find the location, it would be somewhere here. So this point becomes 1 comma 1 in coordinate geometry. Now they want us to find a point z2 which are related by this relation. So if I find z1 minus z0 ka mod, and it is nothing but the distance between the center and this point z1. So I can apply my distance formula and it will become 1 by 2 whole square plus 1 by 2 whole square. And this comes out to be 1 by root 2. We have done this. So once we have done this, now what they're saying is z2 minus z0 mod is nothing but reciprocal of this. So this will become nothing but root 2. So now what we want is basically a point that lies on the line joining z0 and z1. but is at a distance root 2 from the center. Okay, so now we have two scenarios. One, the point can be here, another the point can be here. So let us consider both the scenarios. Let us take case 1. In our case 1, what is happening here is my point z0 is here, that is 1 by 2 comma 3 by 2, and my point z1 is here 1 comma 1, and z2 is on the other side, and let us say that this point is x comma y. Now if this distance is z2 root 2 and this is 1 by root 2, if I find the ratio, this will be 2:1. And next, if I apply the section formula, what am I going to get is x plus 2 by 3 is equal to nothing 1 by 2, or the value of x comes out to be 3 by 2 minus 2, that is nothing but minus 1 by 2. Similarly, if I put y plus 2 by 3, it will be equal to 3 by 2. The value of y comes out to be 9 by 2 minus 2, that is nothing but 5 by 2. So this is the first case that we have figured out. In the next case, or case 2, I can do similar kind of calculation, but in this case my z0, z1 and z2 are on the same side of the line. So in this scenario, this distance is root 2 from here to here, and this distance is 1 by root 2. So if I find the distance between z1 by z2, it is nothing but root 2 minus 1 by root 2, and you can see that it will also come equal to 1 by root 2. So if you look into these ratios, once you figured this out, now what is happening is, after this basic calculation, this distance is also 1 by root 2 and this distance is also 1 by root 2. The ratio between them is 1:1. So here z1 is midpoint between z0 and z2. So if I use this logic, then what I am got is, again if I apply distance formula, assume my z2 as x comma y. So x plus 1 by 2 by 2 will be equal to 1. So the value of x comes out to be 3 by 2. And y plus 3 by 2 by 2 comes out to be 1. So y comes out to be nothing but minus 1 by 2. Sorry, plus 1 by 2. So from the first point of view, the point is nothing but the value of z2 mod would be nothing but 1 by 4 plus 25 by 4. So it is nothing but root of 26 by 4. Wherein if I look into my second case, the answer comes out to be 9 by 4 plus 1 by 4 ka root. That is nothing but root of 5 by 2. So now what they're asking is mod of z square. So the minimum of both of these values is root 5 by 2. That comes out to be option B. Now let us look into this very interesting question that was asked in 2022. In this question, they have given two equations. One clearly and distinctly is the equation of a circle that has center at 3 and the radius is 1 by 2. If I look into the other equation, this is a messed up equation because there are many mod signs put into a single question. How to maneuver through such kind of equation or question? So in such kind of question, your technique should be centered around removing the modulus sign. If I want to remove the modulus sign, I will square it and will use the property that mod of z square is equal to zz bar. So if I do that, this is z0 minus z2 plus 1 and then z2 bar minus z2 plus 1 ka mod, and on the right hand side I get z2 plus z2 minus 1 mod into z2 bar minus z2 minus 1 mod. And if I simplify it, what am I going to get in this scenario is, it will become z2 bar plus z2 plus z2 bar with a minus sign, and then in multiplication we will have z2 plus 1 mod, and towards the end what we have is z2 plus 1 mod whole square. On the right hand side what we will get is same thing, z2 bar, but instead of minus sign we will have z2 plus z2 bar ka mod. In this time we are having positive sign, and the last part is nothing but z2 minus 1 mod whole square. So you can see that the first term gets cancelled out. Once we have cancelled this first term, we have this second term that can be simplified, and if we simplify and write this, what we are getting is minus z2 plus z2 bar in z2 plus 1 mod, plus this can be written as z2 again zz bar, so z2 plus 1 in z2 bar plus 1. And then we have z2 plus z2 bar in z2 minus 1 mod plus z2 minus 1 into z2 bar minus 1. And again, if you simplify this, what we are getting is minus z2 plus z2 bar plus z2 plus 1 mod plus this also can again multiply, simplify and cancel out, and ultimately we will be left with z2 plus z2 bar. And on the right hand side, z2 plus z2 bar z2 minus 1 mod, and again if you simplify this, minus of z2 minus of z2. So we can see that in all of these, z2 plus z2 bar, this equal to 0 is one solution. So what we have, z2 plus z2 bar equal to 0 as one solution. And another thing that we have here is nothing but z2 plus 1 mod with a minus sign is equal to nothing but plus 1 is equal to z2 minus 1 mod plus minus 1. And if I simplify this, I get a very simple statement, that is z1 minus 1 z2 minus 1 mod plus z2 plus 1 mod is equal to 2. Now, interestingly, what is happening in this question is we are getting two different solutions. Now, if I consider the second one, I can also consider the first one. If I consider the second one, something very interesting happens. So if I try and draw it, what is happening is, see, this will represent the locus of those points whose distance, if I take from 1 and 1, sum comes out to be 2. Now, if I try and draw this second locus on the number line, and it will be nothing but a straight line segment between minus 1 and 1, because if I take a distance, take any point between z1 with minus 1 and 1, the distance of that point from minus 1 to 1, if you add it down, it will always come out to be 2. So this becomes nothing but equation of a line segment between minus 1 and 2. And another thing that they have given is nothing but the locus thing, that if I draw is nothing but a circle whose center is at 3 and radius is 1 by 2. So this point, if I look into this point, is nothing but 5 by 2. So the minimum distance between these two is nothing but this distance. And this distance comes out to be 5 by 2 minus 1, that is 3 by 2. If you want, you can also check about this one more locus that is given. But see, you can see that from this diagram, it is going to lie on this imaginary axis, and the nearest distance will come corresponding to origin. And that distance would be 5 by 2. So even that is not the minimum answer. So it will become one of the maximum, not maximum, but somewhere between minimum and maximum answers. Not definitely not the minimum answer. Now this is a very interesting question that came in 2023. In this question, what they are saying is, this is an equation of circle given. Now you can see that just by looking into it, we cannot figure out. So we can put z is equal to x plus iy. If I do so, it becomes x minus 1 whole square plus y square is equal to 4 times. I have squared on both the sides. If you're not comfortable doing a square, you can write it down and then you can do the square into root of x square plus y square. So once you do it, it becomes x minus 1 whole square plus y square is equal to 4x square plus 4y square. And if you do this, what we are getting is x square minus 2x plus 1 plus y square is equal to 4x square plus 4y square. And if I simplify it, what I get is thrice of x square plus thrice of y square plus 2x minus 1 is equal to 0. And if I divide by 3, it is x square plus y square plus 2 by 3x minus 1 by 3 equal to 0. So we are looking into a circle. If I draw it up to the scale, we are looking into a circle that looks something like this, whose center is at a point 2 by 3, comma 0. And if I, minus 2 by 3, comma 0. And if I look into its radii, it is nothing but root of g square plus f square minus c. So becomes 4 by 3 plus 1 by 3. If you look into this diagram, what you will understand is, if I draw up to the scale, this is how it looks like. And we understand that something like this is going to happen. So if this happens, what they have given us is basically, if I take the point on this line, on this circle, then it is being such a manner that a into b is smaller than 0. That would mean either it is in this quadrant or this quadrant. If this happens, important thing is what they're asking is, what is the value? What is the possible value? So now here you can see that since the value of a, we can have value a between minus 1 to 0. It is possible to take these values for a. So what will happen is, your 1 plus greatest integer function of a, this part will become 0. And because of this, your C option is definitely possible. Now let us look into this very simple question that came in 2022. But a very tricky one also, because here the coordinate geometry part and is so strong in this question. If you look into this first circle that they're talking about a circle whose center is nothing but 3, minus 2. And the radius is nothing but n by 4. So look into this another circle. The center is nothing but 2, minus 3. And the radius of this circle is nothing but 1 by n. So what they're saying is, what they have written and what it means is they should not intersect. In simple language, if they intersect, then the deal is broken. Otherwise, it is fine. So for this to happen, we understand that D needs to be greater than R1 plus R2. This condition is there. If you find D here, D comes out to be a root of 1 square plus 1 square. D is nothing but distance between center, this distance. We are applying distance formula, it comes out to be root 2. If I find R1, they have given this value as n by 4. If I say R2, they have given this value as 1 by n. So all we need to do is simplify this equation and find the corresponding values of n, and that is going to be the answer. If I do so, what I can write is root 2 is greater than n by 4 plus 1 by n. Now if I solve this further, what I'm going to get is n square minus 4 root 2n plus 4 is smaller than 0. And if I solve this quadratic, it comes out to be 4 root 2 plus minus root of b square, that is 34, minus 4ac, that is 16, by 2a. 4 root 2 plus minus 4 by 2, which I simplified, comes out to be 2 root 2 plus minus 2. So our value of n lies between 2 root 2 minus 2 and 2 root 2 plus 2. For the first scenario, it is 2 into 1.414 minus 1. Then the second one, if I take 2 common, it is 1.414 plus 1 into 2. So the value of n in this case lies between 2 into point, so somewhere around 0.8 to 2.4 into 2 would be 4 point something. So the possible values of n are nothing but 1, 2 and 1, 2, 3 and 4. Hence the answer becomes option D, 4. Now this very interesting question was asked in 2022. What this question says is, there is this one locus and we can clearly identify this is argument of z minus 1 by z plus 1 is equal to pi by 4. And this is nothing but an locus of a major arc. Major arc because this angle is pi by 4, that is between 0 and pi by 2. And this one, another one, is nothing but a circle. Now this is quite simple to do. This we can easily do. So let us first move from the difficult part, that is major arc. So if I try and plot these points on the Argand plane, what is going to happen is, one point is minus 1 and 1 is 1. So if I start from z plus 1, so let us say that this is the point z. And if I start from here, so this vector is nothing but z plus 1 and this vector is z minus 1. So what is happening is, if I start from z plus 1 to z minus 1, this angle needs to be positive pi by 4. So we can definitely say that it is going to lie on this side. And if I draw the arc, this is how the arc looks like. If I draw a little bit better diagram in the form of a circle, this is how it looks like. So we are talking about this upper part, major arc of this circle, that is this part. And now you can see that this point is minus 1, 0, this point is 1, 0. So the center of the circle, if I try and find, if this angle on the arc is nothing but pi by 4, this angle at the center would be nothing but pi by 2. If I drop a perpendicular from here, this angle, half of this will become again pi by 4. Now this is 1 from here to here. Since this angle is pi by 4, this will also become 1. Okay. So if I want to write the coordinates of the center of this circle, the center of this circle is at 1, 0. If I want to find the radius, it is nothing but root 2. Because angle we know in this triangle is 45 degrees. So once you have figured this out, now we have got a circle, we've got the whole picture. And now, if you look into another circle that is with us, so the center of the another circle is at this point, and the radius is 3. Now this topmost point, even if you find, this would be 1 plus root 3. So 3 would be still bigger. So we can see that this another circle completely circumscribe our current circle. Something like this. And there will be no common point of intersection. Hence the answer becomes C. If I look into this next question, it is a very simple question based on locus. So the first part of the locus says that if you have mod of z plus 1, this needs to be smaller than z minus 1. What does this mean is, if I'm considering a point in the Argand plane, let us mark this point as minus 1 and this is plus 1. So what we are saying that if I consider a point here, it needs to have more distance from 1 compared to minus 1. That would mean if this is the angle bisector between minus 1 and 1, this point needs to lie closer to minus 1 compared to 1. Only then the distance with 1 would be more. Now if I look into the next part says that this locus, that is z argument of z minus 1. If you look into this locus, we already know that this is a locus of minor arc. So now this minor arc, if I draw, is going to look something like this. So if I look into this, this is the minor arc, and what the portion that we need to consider is the portion that is here, the smaller portion. So now if you draw both of these, you can see the common intersection of both of these is coming in the second quadrant. So our answer becomes a portion of the circle centered at 0, minus 1 by root 3 that lies in the second quadrant only. Now this talks about second and third, so this cannot be correct. This talks about empty set, this cannot be correct. And this talks about third quadrant, again cannot be correct. So even if you do not find this center, it does not matter, still you will be able to get the answer correct. Now this very interesting question came in 2019. In this question, what they are saying is, set of all these points lie on which of these following locuses. So what you can do is, we can rationalize it. So if I multiply by alpha plus I in numerator and denominator, I get the value of x plus iy. So if I simplify this, it becomes alpha square minus 1 plus 2 alpha I by alpha square plus 1 is equal to x plus iy. So the value of x comes out to be alpha square minus 1 by alpha square plus 1, and the value of y comes out to be 2 alpha by alpha square plus 1. So this is very interesting to observe that where this is going to lie. So now what we have to fundamentally do in order to get to the locus is eliminate alpha. That is our job that is left in order to get to the question. Now in order to do this elimination, if I do this very simple substitution, or if I can observe that if I somehow replace alpha with nothing but tan theta, so what is going to happen is, here we get a formula of tan square theta minus 1 by tan square theta plus 1. And on the other side, for the y, we get is 2 tan alpha by tan square alpha plus 1, tan square theta plus 1. So what you can see is, in place of x, what we are getting is minus of cos 2 theta. In place of y, what we are getting is nothing but sine 2 theta. So I can eliminate and write x square plus y square equal to 1. You can see that it comes out to be a circle whose radius is 1. Now this is a very intelligent question based on geometry of complex numbers and quadratic. So how to do this question? So what we are going to do is, instead of z, let us put x plus iy. And in place of alpha, let us put p plus iq and simplify. If I do that, what I get is a times x square plus y square. And if you simplify the second part, it becomes twice of xp plus qy plus d equal to 0. And if I write this in the standard form, this becomes x square plus y square plus 2x e by a plus 2q by ay plus d by a equal to 0. What they're saying is, this represents a circle. Yes, definitely it is a circle, but for this to become real circle, the radius of this circle needs to be greater than 0 and a cannot be equal to 0. These two conditions needs to be there, otherwise it will not be a circle. So if this condition is fine, now let us take the condition of r. So this becomes nothing but g square plus f square minus c. So g square plus f square minus c, root of this is nothing but radius. This needs to be greater than 0. And if I put this, what I get is p square plus q square minus ad needs to be greater than 0. Now p square plus q square is nothing but mod of alpha whole square into addition needs to be greater than 0. So now if you look into the options, your second option matches perfectly. So let us look into this 2024 question. Question says that z be a complex number such that the real part of this is equal to 0. So in the first step, what we are going to do is, we are going to put z as nothing but x plus iy. If I do so, this becomes x plus iy minus 2y by x plus iy plus 2y. If you do this, it becomes nothing but x plus y minus 2 times I
Denominator becomes nothing but x plus y plus 2 times. Now once you have this, what we can do, we can rationalize this, or we can multiply by conjugate, and if I do so, it will become x minus y plus 2 times I, and x minus y plus 2 times I. And if I do so, the denominator will become x square plus y plus 2 whole square. The numerator also, what we want is the real part. Imaginary part we do not care, because they are talking about the real part being 0. So that will get generated if these two multiply and these two multiply. And if I do so, this will become x square plus y square minus 4. Now what they are saying is this real part that we have here, this is equal to 0. If this becomes equal to 0, in the second part, we have got the point. Our point lies on x square plus y square equal to 4, that is a circle. Now what they are asking is, if I convert this question that is given to me in a coordinate geometry question, they have given us a circle. There is a point on this circle whose center is 0, 0. The radius is equal to 4. There is a point 6, 8. What is the maximum distance from the circle? So see, maximum distance would be nothing but, if I draw a common normal, the diametrically opposite point, and we know that this distance is equal to nothing but d plus r. So if I apply this, I should get my answer. D will become nothing but the distance between the center. So this is nothing but d, and this is nothing but r. So d, if I check, it is nothing but root of 6 square plus 8 square, and r is nothing but 2. So this comes out to be 10, this comes out to be 2, answer becomes 2. You can see that this technique of converting a complex number question into a coordinate geometry question is a very interesting one. If I look into this 2024 question, it is an extremely good question. Question talks about a circle that is given to you straightforward. In the first part, you can directly write the equation of circle as x plus 2 whole square plus y square is equal to 1, because the center of the circle is minus 2, 0, and the radius is given as nothing but 1. In the second part of this question, if you want to find this locus, you will have to put in the place of z x plus iy like we did in the first part. If I do it so, what we get is nothing but x plus iy plus 1 by x plus iy plus 2. We will have to rationalize this. It can be done as nothing but x plus 2 minus iy and x plus 2 minus iy. Once I do it so, since I only want to worry about the imaginary part that is given as 1 by 5, if I just figure out the imaginary part after solving comes out to be y by x plus 2 whole square plus y square. Once you have done that, this is given as nothing but 1 by 5. So we get equation of another circle, x plus 2 whole square plus y square is equal to 5y, that can in turn be written as x square plus y square plus 4x minus 5y plus 4 equal to 0. So now what they are saying is, there are two circles into place. Let me draw them on a coordinate plane. So this is my coordinate axis. The center of the first circle is nothing but minus 2, 0. So this circle goes like this. The center is minus 2, 0. Another is nothing but minus 2, 5, it goes like this. It touches both the axes. It touches one axis and cuts another. Now what they are saying is, if I figure out this point or this point, it is nothing but x, y in coordinate plane. And if I write z as x plus iy, I get nothing but complex number. So if I do this, now let us, before doing, let us do a simple calculation and find the y coordinate. The y coordinate will lie on the common chord. For finding common chord, I can just subtract the equations of the circle. And if I do it for these two equations, what I am going to get after doing this is nothing but y will be equal to 1 by 5. So you have got the equation of the common chord. This point we have got. If I want to find the another point, what I will do is I will take the first equation, that is x plus 2 whole square plus y square is equal to 1, and substitute this value here. And if I do it so, x plus 2 whole square plus 1 by 25 will be equal to 1, or x plus 2 whole square will be equal to 1 minus 1 by 25. So this becomes 24 by 25. And the answer of, now see, this is an important value because now if you look into the question, they are asking this value. So let us simplify this before doing anything. So if I simplify this and put it here x plus iy, what they are asking is if I write x plus x minus iy plus 2. So they are asking the real part of this. So real part of this would be nothing but x plus 2. So they are asking the value of x plus 2 in simple terms, in fact the modulus of that. So I need to get the modulus of this part. That can easily be done if I take this value and put a root over the other side. So the answer to this question becomes nothing but 24 can be written as 4 into 6. So 2 root 6 by 5. So you can see the option A matches. Now if I look into this next question talks about Z1, Z2 are two distinct complex numbers such that this relation is given to us. Then they are asking this radiuses of these two circles. So now in such kind of question, the technique is to remove the modulus. So in the first step, what I am going to do is I am going to square it. So Z1 minus 2Z2, this ka mod ka whole square will come, and then on the other side it is 4 times 1 by 2 minus Z1 Z2 bar modulus whole square will come. Now what we have is a very interesting idea that mod of Z square is equal to ZZ bar. So this will become Z1 minus 2Z2 into Z1 minus 2Z2 bar, and on the other side you can write 4 times 1 by 2 minus Z1 Z2 bar into 1 by 2 minus Z1 bar Z2. So we have applied this idea that we have written here. So once you simplify this, you almost get your answer. So in the next part, let us simplify this. So this can be written if I multiply Z1 bar. The next part will become nothing but minus 2 Z1 Z2 bar minus 2 Z2 Z1 bar, and ultimately 2 times Z2, 4 times Z2 Z2 bar. On the right hand side, we can adjust this 2 in either of these terms, and this will become 1 minus 2 Z1 Z2 bar, and the second term can be simplified as 1 minus 2 Z1 bar Z2. Let us try and also open this up. If I open this up, this becomes 1 minus 2 Z1 Z2 bar minus 2 Z1 bar Z2, and ultimately the last term 4 times Z1 Z1 bar Z2 Z2 bar. So once you observe this, you can see that these two terms are getting cancelled out. If you simplify the rest, you almost get your answer. This can be written as nothing but mod of Z1 whole square. This can also be written as plus 4 times mod of Z2 whole square. Right hand side can be written as 1 plus 4 times Z1 mod whole square, Z2 mod whole square. Once we write it like this, this can be rewritten as nothing but 4 times Z1 mod square, Z2 mod square minus Z1 mod square minus 4 times Z2 mod square plus 1 is equal to 0. Now this is interesting to understand because this can be refactorized and written as nothing but mod of Z1 square minus 1 and 4 times Z2 square minus 1 equal to 0. So from here you can see that you have got two very interesting terms. One is nothing but mod of Z1 ka whole square is equal to 1. That would mean Z1 comes out to be nothing but 1. So the radius of the circle becomes 1. And it lies on the radius of the circle whose radius is 1. Whereas if I look into 2, what we are saying is 4 times Z2 के mod का square equal to 1, तो Z2 के mod become nothing but 1 by 2. That would mean it lies on the circle with radius 1 by 2. So option C matches. Now if I look into this 2024 question says that you have been given this one S1 set of points, says that this talks about all the region inside the circle. This is 1. So 1 if I plot, this is how it is going to look like. The region inside a circle whose center is at 0, 0.
and radius is equal to 5. So we are talking about region inside the circle. S2 claims to be imaginary part of this term greater than 0. So let us find this S2 also. So in the second part, if I write z as nothing but x, so this will become x plus 1 plus y minus root 3i divided by 1 minus root 3i. So if I rationalize, this will become 1 plus root 3i and this will become 1 plus root 3i. If we will multiply them, and if I do it so, we are only concerned with the imaginary part, so real part will not worry about, so this is fine, but the imaginary part will happen if this multiplies to this term. So root 3x plus root 3, and then this part gets multiplied to this part, that would become y minus root 3. Now add in the denominator, what we have got is nothing but 1 plus 3. So if I look into the imaginary part of this term, this root 3 will get cancelled out. What we are getting is root 3x plus y by 4. This is nothing but the imaginary part. And they are saying that this should be greater than or equal to 0. So you can see that this will also represent a region, because this represents a region. In the third part, what they are saying is the real part of z is greater than 0. So third part is quite simple, x is greater than or equal to 0. Now if I do what they are talking about, the region that is in the intersection of all three. So let us now in the third part, let us say fourth part, let us try and bring them all on the same graph. The first one was nothing but this circle and the region inside the circle. So we were talking about this region. Let me remove those straight lines. So we are talking about region inside the circle. The second part is saying that root 3x plus y. So root 3x plus y should be greater than 0. So you can see that y is equal to minus root 3x. So it would be a line like this. Now what we are saying is it should be greater than 0. So if I take points which are on the right hand side of this, it will also always be greater than 0. So now we are talking about this region between this circle and this line, and then they have also given the third condition, x should also be greater than 0. So we are talking about this region ultimately. So this becomes our answer. Now what they are saying is, if you find the area of this region, so now this is a simple question, because in the fifth part, if you want to find the area of this region, what you will have to find is basically the area of this part. We know that this is nothing but a quarter of a circle. So this can be very easily figured out as nothing but pi r square. So 5 square by 4. So this region can be easily figured out. Wherein you can see that if y is equal to minus root 3x, that would mean the slope of this line is nothing but minus 60 degree. So this angle is nothing but from here to here, this angle is nothing but 60 degree. So for 360 degree, the area is pi r square. So for 60 degree, it is going to be 1/6 of that, so pi. So let us add these two areas. So if I add into this 25 pi by 6, what we are getting is nothing but 25 pi into 1 by 4, 1 by 6. So this comes out to be nothing but 6 plus 4, 10. So 250 pi by 24, or if I divide by 2, 125 pi by 2. Just check the options. So you can see that C option matches. If I move towards this 2024 question says that the area of the region given by this and this equation is. Now if I talk about this first part, they are talking about the region inside a circle whose center is at 1. You can see that the center of the circle is at 1, 0 and the radius is 2. So your circle will go like this. This point will be at a 2 unit distance from here. We are talking about region inside this. The second one, if you want to figure out, what we can do is we can substitute the value of z as x plus iy. So this becomes x plus iy plus x minus iy, and then I times, again we can do that. So x plus iy minus x plus iy is smaller than or equal to 2. You can see that this will get cancelled out. This will also get cancelled out. So 2x minus 2y is smaller than equal to 2, or x minus y is smaller than equal to 1. So this is what we have got in the second part. If I move towards the third, they are saying that y should be greater than equal to 0. Let us find the intersection of all of them in the fourth part. So what we have got is a circle whose center is at 1, 0. So it will be something like this. The center is at 1, 0, the radius is 2, this point will become minus 1, 0. This point will become nothing but 3, 0. So in the fourth part, let us try and take intersection. So we are talking about the region inside this circle. The line is given as y is equal to x minus 1. So in this, if you want to plot this line, all I need to do is put y equal to 0, x will become 1. And put x equal to 0, y becomes minus 1. So the line is going like this. If I put 0, 0, it satisfies. So we are talking about this region currently. And then what they are saying is y is greater than 0. So now we need to find this region. Now what we did in the last question can again be done in this question, and we can find the area. Now in this next problem type, we are going to look into the expression of conics in complex numbers. Now this whole idea is based on two very specific types of conics and two very specific types of expressions of conic. So let us say that if I consider an ellipse, for ellipse what we know is this property that if we have two foci as S1 and S2 and there is a point P, and if I connect this point P to S1 and S2 on this ellipse, the relationship was S1P plus S2P is equal to constant, and this constant is equal to 2a. So this was the relationship that we have seen. And also here also there were 2-3 cases that we need to understand. The cases was if k is equal to nothing but the distance between S1 and S2. In this specific scenario, it is going to become a degenerated conic. That would mean this will represent all the points between S1 and S2, or it becomes a line segment S1 S2. The next part was if this value of k is greater than S1 S2, then definitely it is going to become an ellipse. And the third condition was that if this k is smaller than S1 S2, then it will represent no locus. So it will represent nothing. Fine. So there are these three important scenarios and conditions that we need to consider. Now, if I consider the case of hyperbola, what we knew there was if we have 2 points S1 and S2 as foci, and then there is a point P, then in this scenario, the cases or the conditions were a little bit different. So let us say that this is a point here, and then we have this upper curve like this. So here the conditions were a little bit different. So let us write those conditions and then write the complex number avatar of those conditions. The condition was here nothing but S1P minus S2P mod should be equal to k, where k is nothing but equal to 2a. So this is what we knew. But there are 3 important conditions that we need to follow. One is if k becomes equal to S1 S2, again it becomes a line segment. And you can see that now this will happen when this line is on the other side of S1 and S2. So that part of line segment it is trying to represent. Another condition here is what will happen if k is smaller than S1 S2. So this is totally fine because in this case it is going to represent hyperbola. But if k is greater than S1 S2, in that case it will represent nothing. If I want to write the same idea in complex number, this first equation can be written as nothing but z minus z1 mod plus z minus z2 mod is equal to k. K will have the similar kind of condition. The value of k here, if is smaller than z1 minus z2 mod, will represent nothing. And if k is equal to nothing but z1 minus z2, will represent the line segment joining S1 S2. And in the third case, if k is greater than z1 minus z2 mod, it will represent nothing but an ellipse. Similar way, we can also extrapolate the other idea. Only thing that we need to do here in the second part is write this equation as nothing but z minus z1 mod
minus z2 mod commod is equal to k. And then you can also interpolate the same idea in the similar manner that we did for ellipse. So you don't need to remember these ideas. You need to understand the concept of modulus and remember what we learned in ellipse and hyperbola. This is not a question of complex numbers. This is essentially a question of conic sections properties. Now let us see what kind of questions JEE has asked on these ideas. If I look into this first question that came in 2022, what you will realize is all you need to do in this question is identify the conics, identify the basic geometrical figures, draw them on a normal coordinate plane and check how many points of intersection are there. So the first idea is to recognize this point. So if I draw this is a circle, we can easily recognize whose center is at a point 4, 3 and radius is equal to, this is very easy to identify. But if you look into this one, this comes out to be an ellipse where z minus z1, if you compare with this equation, z minus z1 mod plus z minus z2 mod is equal to k, where this is nothing but twice of it. And for this to become ellipse, k also needs to be greater than z1 minus z2. That it is, because z1 minus z2 is 4 and this value is given as 6. So that is fine, so it is an ellipse. So once I draw this ellipse, what you will observe here is, you have drawn it, one of its foci will be at a point 0, 0 and another foci would be at nothing but 4, 0. So the midpoint of these two would be nothing but center. So our center is at a point nothing but 2, 0. Now what we are saying is, what we need to figure out is, see, if you look it from a geometrical point of view, the center of this is 4, 3. So if I actually draw it on the coordinate plane, this is going to look something like this. There is a line that is passing through one of the foci. This is one of the axis, this is another axis. And then if I look into my circle, and it is somewhere up here because it's 4, the x coordinates are matching. So it is in line with the other foci that we have. So our important consideration would be to find this point, that is the end of lattice rectum passing through 4, 0. For this, what will require the value of b. Now in the question, what they have given is the value of 2a, that is given as 6. So from here, the value of a comes out to be 3. This part is fine. In order to find the value of b, what we have is the distance between two foci is equal to nothing but twice of a. So 2 times a into e will be equal to nothing but 4. So the value of e comes out to be 2 by 3. And if you simplify this, 1 minus b square by a square is equal to 2 by 3. So from here, the value of b square, if you calculate, comes out to be 5. So now if I want to find this extremity, this distance from here would be equal to nothing but b square by a. So if I find my b square by a, b square is nothing by 5, a is nothing but 3. So this point, and this is 4, 0, if I go 5 by 3, this point will come. So this is 4, 5 by 3. Now this is very interesting. Why? Because now if I overlap this circle on this diagram, let us see what happens. If I overlap this one, the center is at nothing but 4, 3. The radius is nothing, so it will dip down 2 units from here. So the point that is vertically below this point 4, 3 is a point 4, 1 here somewhere. So for this to happen, you can see that it will have to intersect at 2 points, and hence the answer becomes nothing but C option, that is 2. Now this very beautiful question was asked in 2023, and the biggest problem with this question is understanding what they're trying to say. So see, what they're trying to say is, if there is a point that follows this trend z plus 1 by z, where z is coming from this curve, then what is going to be the locus of that point? So let us say that this complex number ultimately will be equal to x plus iy, because we want to find the locus, and this is equal to z plus 1 by z. Now you can see that for finding the value of z here, we have another equation given here. What this equation says is mod of z is equal to 4. That means z lies on a circle like this. If z lies on a circle with a radius 4, and if I consider one point at an angle theta here, that is nothing but argument, this point can be written as 4 e raised to the power I theta on argument. So you can see that any z on this curve can be represented as 4 into e raised to the power I theta, which is also the parametric form of a circle. If I do that, here x plus iy can be written as 4 e raised to the power I theta plus 1 by 4 e raised to the power I theta. And if I simplify this, it is 4 e raised to the power I theta plus 1 by 4 e raised to the power minus I theta. And again, if I simplify this, what am I going to get is 4 cos theta plus 4 times I sin theta. And the next part becomes nothing but 1 by 4 times cos theta minus 1 by 4 times I sin theta. And now if I write x plus iy, that is nothing but
4 plus 1 by 4 times cos theta, and then 4 minus 1 by 4 times I sin. Value of x comes out to be nothing but 17 by 4 cos theta, and value of y comes out to be nothing but 15 by 4 sin theta. So if you find equation of this curve, it comes out to be an ellipse. And if I plot this ellipse, you can see that this is an ellipse with center at origin and is in this shape. So this is how my ellipse look like, with the center at 0, 0. And the value of a, if you write the equation is coming out to be x square by 17 by 4 a square plus y square by 15 by 4 square is equal to 1. So what we have done is cos square theta plus sin square theta equal to 1. Cos theta we find from the first equation, sin theta from the second equation, and we got our answer. Once we plot it, you can see that the value of a here is 17 by 4. Now 17 by 4 is slightly greater than 4. And the value here is nothing but 15 by 4. So this value or distance is 15 by 4. This distance is 17 by 4. If I overlap with my curve that was earlier a circle, and you can see that from here they will have 4 points of it. And hence A option becomes correct. Now this extremely simple question came in 2020. In this question, what we have to do is what they're saying in the question. So just put the value of modulus here, and this becomes x square plus y square root. This becomes minus of x is smaller than or equal to 1. So if I take my x on the other side, it becomes x plus 1. Now if I square it, what I get is x square plus y square is smaller than or equal to x plus 1 whole square. If I simplify, it is x square plus y square is smaller than or equal to x square plus 2x plus 1. X square and x square gets cancelled out. So y square is smaller than or equal to 2x plus 1. And this is given in option B. That comes out to be our answer. Now let us move towards the last problem type of this chapter, that is problems based on mixed concepts in geometry. Now let us see the first question that came in 2005, and I am very sure that this kind of question can again hit you this year in 2024. In this question, what they're talking about is a region that is given to us in the diagram, and they're talking about which of these following option is synonymous with the locus of this region. So now if I look into this, they have given this point P at minus 1, 0. And if I look into this point, if I take any point here, and if I want to write this vector is going to be nothing but z minus minus 1. So this becomes nothing but z plus 1. So whenever I'm looking into any point, that point is nothing but z plus 1. Now, what they are showing is the region that is at a certain distance from this point. Q they have given us as nothing but minus 1 plus root 2, comma root 2. R they have again given us. So if I want to find the distance of PQ, I can apply my distance formula and figure out this distance. So distance, if you see PQ, if you find the distance, it comes out to be nothing but root 2 whole square plus root 2 whole square root, and that is nothing but 2. So you can see that this distance of PQ is nothing but 2. So this is the circular radius between P and R. That is what we can understand. Now once you've understood this, if I'm talking about a region that is outside the circle, it is nothing but z minus z1 mod is greater than 2. Here z1 is nothing but minus 1. So this region becomes z plus 1 mod is greater than 2. Now let us look into the option. You can see this option, first option, and third option talks about this area. So this B and C, D cannot be correct. We have eliminated 2 options. Now the second part is they are talking about an arc, a circular arc kind of a thing that is getting formed. So now for this, we have different types of arguments. So what we are, if I take a number, you can see that the maximum argument or angle here is nothing but pi by 4. And the minimum is minus pi by 4. So I am taking those numbers whose argument lies between minus pi by 4 and pi by 4. You can see that from this point of view, this option also, this part also matches, this does not matches. And so our option A becomes correct. So you should have 2-3 ideas for doing such kind of questions. One is the logic of modulus should be clear. What does this means? This would mean a region outside circle. This would mean a region inside circle. These are the first set of ideas that should be clear to you. Second is the argument based ideas. So if I'm writing argument of z is equal to pi by 4, it represents a ray. This we already looked into earlier. But if I write argument of z lies between 0 and pi by 4, it is the region between 2 rays like this. So this is 0, this is pi by 4. So whatever points comes between these 2 lines and are going to have an argument or angle between 0 and pi by 4. So this is another idea or the third idea that should have in your mind for doing such kind of questions. Now, here I have given for z minus z1 will shift the origin to that point. If you remember these 3-4 simple tips, all such kind of questions you can do, and I'm sure one question can come on this idea in 2024 this year. So you might have seen multiple such questions in the exam where they talk about general terms Z, A, B, C. So there is a very small and a very clear trick to solve all such questions. Consider some value of Z and preferably something that will make it stand apart. Let us say that Z is equal to 4, and obviously it is a complex number. And since the answer is also given in terms of Z, we can also substitute Z equal to 4 in the options and see what the options are. So correspondingly, my options modified to 1, 8, 1 by 2, and this if I calculate, it is nothing but 1 by 2 into 4 square into root 2 whole square. So this becomes nothing but 16. So you can see that my options also got modified by putting Z equal to 4. Now I can easily plot these points considering them as coordinates. So this point becomes 4, 0. This becomes 4i or 0, 4. And this last point becomes nothing but 4 plus 4i or 4, 4. So you're talking about a triangle when you join these points. That triangle is this triangle. If I apply the formula of half of base into height, so 4 into 4, my answer comes out to be 8, and that matches with my option number 2 or B option. Let us see this next question that came in 2022, and is the combination of 2-3 ideas. So one is this circle. So if I draw this circle, it is a circle whose center is at origin. So my axis will pass something like this and like this. And the radius of this circle is 2. So this point becomes 2i. This point becomes minus 2i. And then they're talking about, if you carefully observe, a locus that is z minus i ka mod is equal to z plus 5i mod. We have already talked about this. This is nothing but an equation of a perpendicular bisector. So if I mark these points, my I would be somewhere here. My minus 5i would be somewhere here down the line. And if I talk about their midpoint, it is a line passing through this point minus 2i. We are talking about this line. You can see that the point that satisfies both the curve is only one point, this point. If I talk about this point in coordinate plane, it is nothing but 0, minus 2. So what they are asking is, this 0, minus 2 is satisfying which of the following options? The question is very simple. So if you satisfy all the options, you will find that your C option is satisfying it, and hence it becomes the answer of this question. So if you can interpret complex number in terms of coordinate geometry, your solution becomes extremely short and fast, and you can do such kind of questions in 30 seconds. If you put everything in Z is equal to X plus Y, it is going to take a lot of time. Now this beautiful question came in 2021 that combines the idea of relation between roots and coefficients from quadratic, the idea of geometry of complex numbers, and some basic manipulation to get to the answer. Let us see what does this question says. So let us say that there are two roots here. So if we have two roots z1, z2, then the sum of roots is nothing but minus a, and the product of roots is nothing but equal to 12. This is one set of results that we are getting from the relation between roots and coefficients. Now what they're saying is, if I take this roots z1, z2 and origin, they form an equilateral triangle. Let us say that the equilateral triangle is of this format. So this is my z1, this is my z2, and since this is equilateral, this is pi by 3, and these both sides are equal. So if I apply my rotation, because it becomes a standard case of rotation, I can write z1 by z2 is mod of z1 by mod of z2 is equal to e raised to the power I pi by 3, and since it is equilateral, then mod of z1 should be equal to mod of z2. So what we get is z1 by z2 is equal to e raised to the power I pi by 3. So you can see that rotation came into picture. Now if I square this first equation that we had, so z1 plus z2 whole square will be equal to a square, and this becomes z1 square plus z2 square plus 2z1 z2 is equal to a square. And now if I divide this by z1 z2, something very interesting happens. So I have divided this by second equation. This becomes z1 by z2 plus z2 by z1 plus 2 is equal to a square by 12. Now if I put the value of z1 by z2, it is e raised to the power I pi by 3. The second one will become e raised to the power minus I pi by 3 plus 2 is equal to a square by 12. And now if I simplify, I get my answer really fast, because this is nothing but sum of number with its conjugate to twice of real part, that is 2 times cos of pi by 3. And if I simplify this, I get the value of a here. So if I do this, this is 3 into 12 is equal to a square. So mod of a is nothing but 6. You can see that how beautiful this question has been framed. There is a part of the question that comes from rotation. So this part comes from rotation. There is another part of this question that is coming from quadratic, and then this is manipulation. This specific manipulation that we are doing here is again very beautiful. You have to square and then divide. So multiple parts coming together and small lot of results, like here also if you use this result. So multiple results coming together to make a very beautiful question. Now let us look into this last question of our discussion that came in 2021. It talks about three different kind of locuses. If you look into the first locus, it is nothing but the region inside a circle. So if I draw the circle, it is x minus 1 whole square plus y square is equal to 2. The second region talks about the real part of this. So if you multiply, what you will get is x plus y. What they are saying, this is greater than equal to 1. And the third locus, they are talking about y is smaller than equal to 1. Now if I look into the plane in which we are drawing all of these, so let us draw the third one because it is the simplest one. So what we are talking about a region that is smaller than or equal to 1, where y is. So what we are talking about is this region. Let me highlight it. So this is the region that we are talking about, but that is below this line. This region we are talking about. Now what they are doing in the next one is they are giving us a region that like something like this. So this is the equation of this line, x plus y equal to 1. And if I put 0, it is not satisfying. So we are talking about this region above this line. So if you look into this region, it comes out to be something like this. So we are talking about this region here. Now if you draw the third part, that is the circle, it has a center at 1, 0. So this is my 1, 0, and the radius is root 2. So if I try and draw it, it would be something like this sort. But after drawing this, what you can observe is, it is not just this. We want the points that are inside this circle. So inside this circle, there are many points. So if I find the common area between all of these three, you can see that this part would be common. Hence, there are infinitely many points that are satisfying all the three locuses. Hence, option C becomes the correct answer. Now, let us look into this distribution of problems according to problem type. So, you can see that what has happened is most number of questions that are asked are into 2 or 3 important problem categories. So, one is nothing but you can see maximum questions getting asked from circle and conic section. So, this needs to be prepared well. Lots of questions have been asked. Second important area had been the algebraic form. So lots of equation based questions are getting asked, and then properties of modulus and exponential form. So these are the important areas that you as a student should definitely prepare. If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time, and based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited no or good preparation, and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details, and somebody from my team will get in touch with you.